Okay, good morning, everybody. I see around 17 people. I waited for some time, seeing if people would join. So I see 17 people are okay. Let's get started. I hope I'm audible and my screen is visible.
Yes, sir.
Okay, so I created a workspace, but I think I messed it up. But let me open a project that I created. So that's the project. I called it as collections demo. Could be anything, but just call this collections demo. Today we'll be working with collections, different types of collections, why collections are required, etc., etc. Uh, there is a huge set of what do you say, classes and interfaces that were introduced. So we are currently using Java 11, but when Java version 1.0 came, you need to know that they actually came up with Java because C++ they were not happy with with the way C++ works. At that point in time, in C++, the only thing that you can do is you can create an array out of the box, and then using the arrays, you can probably arrays and pointers. You can probably build linked lists, binary trees, using some data structures and algorithms. You can work on all those stuff. But it so happens that in every new project that I work with, I have to start working on or designing my own binary tree or binary search tree or a linked list. And as a developer, I have to focus on most of those common functions. So whether I use a linked list in a banking application or a shopping cart application, the linked list is same. The content stored in the linked list would be different. So can we have a reusable set of data structures? And that was the question asked. And the Java guys, they decided that, okay, in arrays, we have some issues. And as a developer, I don't have to focus on the internals of the data structures like linked list and binary trees. When I say add an element, I should to be adding it to the beginning, adding it to the end. It shouldn't be my concern. As a developer, I just should be able to use a ready-made data structures, just like how I can use a ready-made integer without having to worry about how that integer is converted into binary and stored in the memory. So just like that, I should be able to use a data structure. Just have to say, for example, include that in my project, and I should be able to use that. So to this end, they came up with the two primary classes in Java version 1.0. One is called vector. As you can see that it was introduced in version 1.0. And this vector basically allowed people to, at that time, so a lot of things have changed over a period in time, allowed people to add add an element. For example, you can see that you can add an element over here. Don't worry, what is that E there? So we'll come to that in a few minutes. But then remove an element, add, remove, empty that, clear that, check whether we can add or not. There are many functions they introduced with it. There was one more class that they introduced at the time called dictionary from Java or util again. You can see it is since version 1.0. Dictionary provides a way of adding an element into the collection using a key here. And whenever I want, I can supply the key and then get the value corresponding to the same. So that was basically the concept of this dictionary. So similarly, you have that in other other programming languages like Python, for example, or PHP. They call it as associative arrays. Then JavaScript. Anyway, every object is basically a dictionary. So essentially, you have all these functionalities in these classes. But soon they realized that this has got a lot of potential because somebody is probably saying that, okay, I'm not happy with the performance of the vector. Can I use another one? It's like, recently I had to change the tires of my car. And when you go and check, so let's say I had a Goodyear tire which came with the car. I wanted to change, and I knew that my Goodyear tire has given around 50,000 kilometers of life. Can I go with something else? Now I can go to the market and look for MRF, C8, and so many others, right? But again, what if I'm not happy with that? So happy with the performance of that. So that is where we have a choice. But in Java 1.0, there was no choice. So 1.2, I believe 1.1, they introduced something called list. And this is something, or rather, I should say, collection. We'll come to that. So version 1.2 actually. So if I go to the collection as an interface from java.util, you can see this was introduced in version 1.2. Then they came up with the concept of interfaces, providing standard contract. So standard contract for all different kinds of collections, and they have provided out of the box many many implementations of these interfaces. So as a user, I have few choices. If I don't want to use arrays because arrays have some problems, fundamental problems like they cannot grow and shrink, you know. And as a developer of a banking application, I don't want to focus my, I don't want to bring my focus to say index plus plus, index minus minus, shift all the elements, etc. So I don't want to really work with the raw arrays, but I want something else. Like they provided basically a bunch of collections. As you can see, collection of interfaces. These are all many of the interfaces and classes that you can see over here. So we will look into few of them. But essentially, there is an interface called collection. There's an interface called collection. So the first one that we will look into is an interface called collection. This is from java.util. Java.util hosts many such classes and interfaces. So I'll just put a interface I for interface, C for class. Okay, give me 1 second. Okay, so let's say we have a collection. So what are the functionalities of collection interface? Now you may see some strange notation here that we haven't used so far. So we'll look into that in few minutes, which is called generics, okay? But ignore that for a minute and then look at the interface called collection. Again, right now we are looking at version 11. So all the source code that we are looking at would be updated to the version 11. So a lot of enhancements over version after version. So some of the functions that if I look at here, now if you have an object of a collection type, now remember collection is an interface. So we need to have an object of that. We'll see how to get that object. Now if you have an object of a collection, you can add an element, add all elements of another collection to this collection. You can clear this collection. You can check if there is an object present in the collection or not, Boolean. Again, the similar one. So if you have a bunch of objects, you want to check if they all exist in my collection or not. So that's again, it returns true. There's an equals hash code, ignore that. There's an is empty, returns true, is the collection empty. Then something called iterator. Don't worry about the streams. We'll have a separate session about streams. There's something called parallel stream here. I can remove an object, remove all bunch of objects from here. Then there is again remove if a condition matches. So there's again another option over there. Retain all and remove all, opposite, kind of complementary to each other. Retain all means, okay, I have a bunch of collection, I have a bunch of objects that I want to retain and then remove everything else. Remove all means I'm giving you a set of objects that I want you to remove. So it's kind of complementary. A size of a size of a collection, and then we have few other options which are not significant right now, but eventually we will be using them. Okay. So basically, a collection defines a set of contracts. Imagine you are supposed to write an implementation of this. If you write a class that implements collection, you need to write all these functions. And as long as you take care of these functions, Then you have your own collection. There is no mentioning of where to add the element. We simply say add an element. Is it added to the beginning, added to the end? This is an abstraction, so it hides the implementation details. So that means you are free to do whatever you feel right. Okay. For each of these functions, you can implement them with an array, for example, or if you want, you can use a binary tree behind the scene or a binary search tree, graph, whatever you want. Use them and implement the features. That's all. Now, there is no class that directly implements this interface, but there are two sub interfaces over here. Okay, so I'll explain with the help of this. One is called list. Let's have a look at the list. Okay, so I have a interface called list. So there is a child, two child interfaces. Actually, three of them are there. We'll write all the three here, but the third one is really not that useful to us, though. There is an interface called list. There's an interface called set, and there's an interface called queue. Okay, so all of these are child interfaces or sub interfaces. They extend, which means they provide additional functionality to additional functionality. And this is an extension, so I can write with an arrow like this. All these are interfaces. Interface can extend one or more interfaces. So in this case, they all inherit from collection. Okay. Now, if you look at the list as a interface, okay, list as a functionality, look at the functions over here. There are functions basically that makes use of an index. Okay, so there are sorry. So if you look at the functionality here, there is a, this is inherited from, you can see that there is a mentioning of an up arrow here, so indicating that it is an overriding function or inherited from collection. But the one without that collection, you can see here also one more is inherited from collection, but this one is not inherited from collection. So what does it do? It not only, you can say it not only provides a sub, what do you say, allows me to add, but it also takes index as a parameter. So which means I can add at a given index. Here also there is one more called add collection, add another collection, but to a given index, right? So that's basically the specialty of this, which means the functions that are introduced over here, such as this one, for example, is another one. Most of the functions which are introduced here, addition to the collection interface, they work with indexes, all index-based operations. So here you have a function to get the element at a given index, get the index of a given element. Then you have last index of, and there are a few functions like this of, ignore them. I'll explain what are those eventually. Remove an element at a given index. This is remove an element at a given index. This is the inherited function to remove an object. You have to give an object and remove, but here you give an index and remove. Again, you have the few other options like set the value at a given index to some other value, and few things like that. And then you have another one called sublist. Given a from index and an ending index, starting index, that from index and to index, you can actually get the sublist of that. So these are three major interfaces, but set provides index-based operations, right? So I can just type here, list provides index-based operations. Based operations. This is a, you can consider this to be a orderly or ordered collection of items. Collection of items, and provides index-based operations. Okay. This one queue, on the other hand, if you look at the queue as an interface from java.util, There are only few functions that are available, which are basically element gives you one element. This is basically the DQ operation. This is basically this is the NQ operation where you're trying to add an element. This is to remove an element. This is to see the topmost element and remove an element. So we have here some operations. Now, most of the time, we don't use this queue directly, but internally, Java itself uses these things. Okay, so basically, it provides a queue functionalities, nothing else. Um, Provides an object of queue interface provides the queue data structure operations, nothing else. What about set? Now, if you look at set as an interface, java.util.set, and look at the members here. Most of these functions are inherited from collection. If you look at Java 8, then all of these are actually inherited from java.util.collection. Forget these functions called off and look at the rest of them. Again, you see that all of them are inherited from the collection. Literally speaking, apart from these off functions, which are of no use right now, you can ignore them. I think they are static functions anyways. So most of these are of no use. The off functions are not, we're not going to discuss at this time. So essentially, the set doesn't introduce any additional functions. Set doesn't introduce additional functionality, but it sets a contract to the developers of this developers who implements this is that it has no duplicate elements. That's more important. Okay, so essentially, this one, an object of set contain doesn't contain duplicate elements. Okay, that is the primary goal of this set. So it doesn't provide additional functionality, but it ensures the developers of set classes that implement set interface must ensure that there are no duplicates. Now, how do you ensure that there are no duplicates? It's up to you. Okay, but again, instead of we creating a class for all these things, because remember the original idea here. The original idea is that we want to choose between multiple implementations based on the requirement and performance benchmarks. So these are the three implementations or three interfaces. Okay, so whenever you think you need a collection, the first question you have to ask is that, hey, what is my priority? Is having non-duplicates is priority? Then go with a set, right? No, I just want a basic collection, then go with a list. Index-based operations, go with a list. Do you want NQ, DQ operations, push, the polling, peek and poll, those kind of functions you want, then go with a queue interface, an object of queue interface. All right, so while we can create variables of this, we cannot really create an object of this, right? Because it's an interface. So what do? Now we need to have classes. So what are the various classes we have here? Now, there are many classes that are available. Let's just take these in different colors so it will be easy for us to recognize. So let's assume that these are the interfaces. And I'm going to take up a class, okay, and change it to some other color. And I'll type here, this is a class called Arraylist. So Arraylist is a class that implements this interface. Obviously, implements is given in a dotted line like this. Let's keep it like that. So Arraylist implements list. Like the name suggests, it is an implementation of a list, but using an array behind the scene, right? So this is the interface that it implements. This is the methodology or the technique that it uses. Then there is another one called as linked list. And here The array occupies continuous memory. So if you have 1 million, data, each data occupies around 20 bytes, then you'll have 20 million bytes, like 20 MB approximately, which is continuously 20 MB is always a difficult task because the way memory is managed, you always want to swap between memories and stuff like that. So there is always a lack of continuous memory in the RAM. So Arraylist is okay to some extent, but if you think that I don't want the continuous data, then you go with a linked list. You also have another class. Remember, version 1.0 introduced a class called what is the class? Vector. So you have a class called vector here, but it was already there by the time they had created. So they had to rewrite everything in the vector class. Okay, they had to rewrite certain things in the vector class. We will discuss about, hey, when I want a list, I have three choices, which one I should take first. So the vector class also has another class, which is called stack. Stack. This time the arrow is a solid arrow because it is a extension. It's an extension. So which one I should go for? So Arraylist is the default choice because they're faster. Arrays are always faster compared to anything else. Like if you have a concept of linked list or whatever you have, arrays are always going to be faster because of the way they are organized, and they are actually accessed using mathematics, like multiply the size with the number of elements, and so let's say you want an element at index 7 and it's an array of integer, and you know that integer takes 4 bytes, and so the seventh element uh, is after 6 integers. So 6 into 4, 24. So after 24 bytes, if I jump from the starting point to 24 bytes, I'll get the seventh element. So I don't have to go and check each element saying that, hey, are you the first element? Are you the second element? I don't have to check that. I can jump directly if I know the index that I want to go there. So arrays are faster. Behind the scene, that's using an array. I'll explain that in a few minutes as how it is working. Vectors also use arrays behind the scene. If you want, you can go and check the same thing. Let's go close all this stuff and open Arraylist java.util. You can see that there is an element, empty element data, which is an array of objects. Okay, and then you have something called default capacity. I don't know, there's no underscore here. Default capacity, empty element data. That's also an object array. If you look at vector class, there also you will see that there is an array. All right, so the array is right here. You can see that there is an array called element data, right? So that's internal structure. Now, usually the default capacity of this, that means initially when the array is created, it will be created as an array of 10 elements, right? Which means every time you're adding, you're just incrementing the index. So that's no problem. But after adding the 10th one, if there is a need of adding another one, 11th one, I don't have space. So what it does is both this vector and Arraylist, what they do is they actually go and check. Every time you're trying to add, it's going to check, hey, do I ensure capacity? Ensure capacity there. That means ensure enough capacity is there to add another element. So what ensure capacity does is it's going to check, do I have enough values, enough elements to add at least one element? And initially you have 10, so the first element is easily added, so the remaining capacity is 9. And every time you're adding it, the remaining capacity starts diminishing or decreasing. And after adding all of them 10, so there is no capacity. So the 11th one, when you try to add, the ensure capacity says, okay, I don't have any space to add the 11th element. What do? I want to copy the existing array of 10 elements into an array of 20 elements. And so that means now I create an array of 20 elements, copy all the 10 elements first to this, and then discard that array of 10 elements. And now I will have enough space to add at least one more element, right? So because I have now 10 more spaces. So I can add one more and one more and one more. Like this, if I add 20 elements, then 21st element will have a problem. So again, the ensure capacity will say that, okay, because I don't have any more space in the array to add another element, let me create another array of 40 elements. So each time it's going to double. So the 20 elements are copied. Now I have space for another 20. And this process goes on. So both ArrayList and vector does the same thing. So it is the add function is the one that is going to take some time, especially when you reach the boundary. Okay. When you reach the boundary and you don't have any more space to add that. Okay. So the same thing happens with vector. So then the choice is that if they had already vector class and they modified that class in version 1.2 to implement all the functionalities of list interface, why did they come up with this array list? So that becomes the question, right? So why do you need to have two classes which do exactly the same thing? So they don't do exactly the same thing because vector class has functions, especially the functions that mutate. For example, if I look at the add function over here, you can see that it is marked with something called synchronized. If I go to the array list and look for the add function over here, you can see there is just public Boolean add, whereas here it is public synchronized Boolean add. So the synchronized keyword is used in multi-threading. That means when multiple threads, multiple line of executions, or multiple lines of executions are executing or working on the same array list or same vector, for example. Imagine a vector is being shared to multiple threads. So when you are trying to add an element to the vector, it should ensure that no other threads simultaneously add or modify the vector, right, or the collection. So ArrayList is not good enough there. Whereas vector, on the other hand, will check, will block that, the vector and saying that, hey, let's say the add function when you're calling, the vector will be blocked. So if there is any other thread trying to add or do something, some manipulation it is going to do, your vector will say, hey, hold on. So there is some activity that's going on. Let that activity finish, and then I will actually allow you to do your work. So the synchronized keyword blocks the vector for the safe updations, okay, safe mutations. So because of which there is a little bit of latency involved. So it is like, imagine I've observed this. It's my observation. Again, I may be wrong, but you tell me, okay. I've seen whenever whenever I go on the road and I see some traffic junction, and there is no police and the signal lights are all off. People are easily they go on easily. There nobody is blocking you. You don't have to stop. Everybody adjusts and goes, no problems. But as soon as the police comes and the traffic police comes and then they switch on the signal light, even if there are no vehicles, enough vehicles, but still I have to wait until the red becomes green, right? So there is a blocking now. So because there is more organized now, but it comes with some kind of a overhead. So because of which, if you look at performance on a single thread applications, vectors perform miserably slower than ArrayList because ArrayList don't have that concept of blocking and unblocking, whereas here the synchronized ensures that there is a lock acquired on that object and released. So acquiring a lock and releasing a lock will actually slow your application down. So there is a performance problem if you are having a single threaded applications. So any functions that are actually going to, use or mutate the vector, they're all synchronized. Here, on the other hand, we don't have such requirements. If you look at remove, it just removes no requirement of being synchronized over there. Okay. Now we didn't do any multi-threaded application, so synchronized will be a little difficult to, or probably it will be out of the context. But anyway, just assume that synchronized means that when this function is using the internal data structure, whatever the array, for example, no other functions or no other threads can actually use the vector. So the vector can be manipulated only by one single thread at a given point in time. Whereas here it is not so. Here it can be done by multiple threads. So the question is, are you using a multiple threads, and are you sharing the vector? Are you sharing the data structure by multiple threads? If the answer is no, then just go with Arraylist because Arraylist are faster. But if you have a scenario where your application has a shared uh, data structure, requirement of a shared data structure shared with multiple threads, then go with a vector. Vector is also called legacy because it was there prior to the introduction of this collection, list, set, queue, etc. So it's an old one, but they rewrote all the functionalities to make sure that it is an implementation of a list interface. So let me know, guys, if you have any questions about Arraylist and vector. All right. So when do you go for a linked list then? A linked list, they don't use arrays behind the scene. They use a concept of nodes. So if I go here and look for linked list in Java, you can see that they have a class called node that has got a first, they have a last. So what does it mean? This is a double-ended linked list, right? So double-ended uh, in here. So basically, doubly linked list, I can navigate from first to the last, etc. Okay. Each node again is available right here itself. You can see node is a class. It's a nested class here. This, where you have a previous, you have a next, and you can construct a node with this element and so on. That's all. And every time you're going to do an add, for example, you can see that your link last, it is adding to the last element, means it is going to add at the end. So basic data structure functionalities are available over here. So when the requirement is of a huge items, and I may run out of memory, continuous memory, or if you have continuous large amount of memory, then garbage collection process will become sometimes slower. Now, with all these problems with a huge amount of RAM, you can always go with a linked list. Linked list will perform better over there. Random access, for example, random access is slower in linked list because it has to go and check. Let's say, for example, I have a million data and I want around 250th record. And I have to start from the first and then start accessing, I start accessing the element one by one in a loop and then go and get that. For example, if I use the get function over here, you can see that it says it is return node of index. So if I go here node of index, you'll see that it's basically going to the next element in a loop, and once it is done, it is actually returning, right? So this is an order of n here, whereas in case of an array, it will be an order of one. You just go and access that with a multiplication. So
I can't believe you. Can you actually do that?
okay, so okay, I think Sakshi exit the meeting because of some noise. Anyway, kids are always naughty. So let's come back to our application. So as you can see that this is actually going one by one, and until it finds that index, the index you're until the index you want to get, and then we are returning that. So linked list is slower in terms of access. I'll share an image that was I think I was having a recent session. So let me just see if I can bring that. Uh, here only it is there. So let's go to this data structures. I think it was in the day 4. I'll just quickly show. there here. So let's go and open this. It's from a Medium page. So accessing is an order of one, as you can see that it's arrays order of one. Whereas if you go to a linked list, it is order of n because it has to go. So it is slower compared to that of an array over here. Okay. So coming back over to our collections, we have to use linked list only when your insertion deletion insertion uh, is more commonly used than retrieval. Okay, getting the first element always is easier. So you can see that getting the first element is faster in case of a linked list. Of course, array list is always faster compared to other things. Okay, so memory versus speed. So this is going to occupy contiguous bytes. Here, there is no such requirement, so you will go for that. You also see that there is a class called stack, which inherits from vector stack from java.util. Again, the functionalities of a stack being like push and pop and then peek, these are implemented in the stack. Again, if you want a stack, you can straight away use that. But only one thing is that push and pop are synchronized, not synchronized, but you can see add element here. Add element is synchronized. So even though I am calling the push function, which is not synchronized, but this part is synchronized, which means it might be a little slower. So it is better to build your own stack using Arraylist or linked list, okay, instead of using this, unless if that performance problem is not really going to hamper your application, okay. All right. So we know that there is a list that we will use, but at some point in time, you may say, I want only non-duplicate values. I don't want to duplicate values in my data structure. So that is when you go with something called as a set. So when do you go with a set? Simple. I don't want duplicate objects. What is the question is what is duplicate? For example, if I say 10, 20, 30 or numbers are there, numbers, we know that the two numbers having the same value will be duplicate. So the notion of equality is or identity is something that is important here. So when you are working with a set, uh, for natural values like numbers and strings, that is no problem. When you start working with the custom objects, you will have to define how do you consider two objects as duplicates. Because two objects, if you simply compare and say person P1 and person P2, P1 double equals to P2, they will always come back with false if they are two different objects, even with the same values. So you will have to define some information, something like, um, hey, if all the values are same in both P1 and P2, then you consider them to be equal, otherwise they are not equal. So you'll have to come up with that logic. So once you identify that the concept of equality, then you have different concepts. Number one here, let's use this itself as a duplicate. One is here called a hash set. Hash set. So hash set implements the set interface. Okay, it implements the set interface. Apart from hash set, there is also one more called linked hash set. It is going to it is an inherited member from here. It's a except that it doesn't use array behind the scene. So this uses arrays behind the scene. I'll tell you what else it uses behind the scene, but that is how it is. You also have another interface here called sorted set. Sorted set. Okay, and then we have another another class here called the tree set. Now they may not directly implement. There might be some other hierarchy also, but essentially this is called tree set. Okay. So if you have worked with a binary search tree, so here is one that uses something similar called as a red-black tree. So when you have a set, the only thing that concerns is that I don't have duplicate values. So this uses basically an array behind the scene, and this uses a linked list behind the scene, and this uses a binary search tree called as a balanced binary search tree, which is called as a red-black tree. But essentially it's a BST. So obviously, you can say that, okay, I just want no duplicate elements, which one I should go with. So default choice should be hash set. Default choice should be hash set. Don't have to go with anything else. But when you're working with the hash set, the order of insertion and order of retrieval may not be same for some reason. I'll tell you the reason a bit later when we actually take the code. If the order of insertion is important while retrieving, then go with a linked hash set because it will maintain a sequence. This doesn't maintain any sequence. When the tree set here, because it's a binary search tree behind the scene called red-black tree, this has got an advantage of add whatever the order you want. We will store it in because we are storing in a BST. So it is going to be retrieved with something called Inorder Traversal. And when you do an Inorder Traversal, you get all the elements in ascending order. So because of which, if that is another advantage apart from just not having duplicates, you also have an advantage of what do you say? So advantage of ordered when you retrieve. So I'll show you with an example. So depending on your requirement, go with the one of these three. Hash set is the default choice. If the order of retrieval is important, it has to match the order of insertion. Then go with the linked hash set. But if the order of the data should be based on the order of elements, some kind of a sequencing, then go with a reset. Okay. We will not be using queues anyways, but there are a couple of classes called, let's see here, there's one called priority queue. You can see there's something called priority queue. I'd extend something called abstract queue, and abstract queue implements implements queue here. So essentially, they're all queues. I generally don't want to go in details of the queue because most of the time these queues are internally used rather than we using it by ourselves. Okay, but just to complete this picture, I'm going to write here one called priority queue. Basically, priority queue is where every element will have a priority. Like VIPs. They have a little bit of or probably elderly elements in a queue. So they will have, say, senior citizens who will go in a separate queue. So there is a priority queue here also. This is overall, and the picture is actually even bigger. If you go to the internet here and look for, Java collection framework in depth. If I look at, there might be more complex pictures that will explain. Let's look at this one. You have a iterable as one interface that your collection inherit from. So iterable means that I should be able to iterate over that. Basic requirement of a collection, isn't it? So then you have a collection, you have a set list. List has something called abstract list. And abstract list has got array list, vector. Then you have an abstract sequence list where there's a linked list. A vector has a stack. So you can search for more complex ones, okay? But get the bigger picture over here. You have three different types of collections: list, set, and queue. The default preference should be list. And in the list, you have different kinds of three different primarily implementations. You can come up with your own implementation, which can perform better in certain scenarios and use them as well. In here, Arraylist is the preferred one because arrays work faster. Then linked list is going to be better when you are trying to, your operations that you're performing is primarily focused on insertion rather than anything else. So the time spent in insertion is very less compared to that of array. Arrays actually have got an order of n, whereas linked list have order of 1. So insertion. So again, depending on what is your requirement, choose one of them. In set, you have by default, set is used or preferred when you want no duplicates in your collection. Then preference is given to the hash set because they're faster, they're behind the scene arrays. A linked hash set maintains the order of insertion. So when you retrieve the data, the order of insertion matches the order of retrieval. And if that is your requirement, you go with a linked hash set. Go with a tree set if retrieval should be in ascending order of the elements. Okay, no matter what you have inserted, while retrieving it will be in ascending order. And of course, queue you will use in very rare scenarios. All right. So now that we have understood basic collection framework hierarchy, now let's understand one more concept called generics. So I want to give an example first and then show you how this works. Okay. So I go to src main Java, create a new Java. Let's create a package first called com.targetindia. Let's call it as programs. And I want to create a Java class here. And the name of the class is called generics demo. And I'll say don't ask again and add to Git. So I want to give a demo on generics and how you can work with this one. Okay. So first of all, what is generics here? So generics allows us to use a class with the different data types for members. Okay. So how do we use this? How do we do that in here? So if you have used something called in C++, there is something called runtime type identification, RTTI. So a class has member variables, but the data type of the member variable I can decide when I create an object. And that is basically what generics allows us to do. Okay. So different types of generics exist. One is like a generic method is there and generic classes exist. Okay. Generic method takes parameter and return some value after performing the task. But we will define what kind of data it is supposed to work with. What is the kind of data we are supplying? So we look at an example of basically a class that works with generic data types. So although in a single Java class, I don't code in Java single Java file, I don't code multiple Java classes. This is an exception, so I'm going to create here. So I'm going to create a class called test, and then I'm going to use a special bracket here and then type here T. Now the letter T can be anything you want. You can type anything. Now generally I type T for type or E for element, etc. So the way I can use in my code is something like this. Let's say, for example, I have this main. I can say test of string, and I can say T1. And then I can say test of, let's say, integer T2. So now T1 is a variable. Of course, I haven't created an object of this yet. So I can always create an object by typing T1 equals to new test like this. Okay. Notice it will probably give you a warning. Ideally, we generally give it like this, indicating borrow the data type from here. In the version 5, it was introduced. So in the version 5 and 6, you had to give like this. But in the version 7, they said T1 is declared to be a test string data type, test of integer type here. So I can borrow that from the declaration of this T1. So we don't have to really give that. Similarly, I can say here T2 equals to new test. Okay, like this. Now imagine I have a function here, or I want to internally declare a variable, but that variable has to be of string type for T1, integer type for T2. So I'm going to say here something like, say for example, T, and then I will say here member. I'll just call it as member. Okay, T member. I can also write a constructor here. So public test, and then I can say public test. What is the parameter that we're going to receive? Let's receive a member. And then we can say this dot member equals to member. And I can also have a good practice default constructor. So I can have a default constructor called the test without doing anything. And here I'll say public. I can call this as private here. And let's say, for example, I want to say here a function that returns t type. I'll call it as times, and I'll take an int num. So I basically want to multiply that so many times. So I need to return something. For the time being, I'm going to return null. So essentially, I can supply here, say, Vinod, and I can supply here 123. And let's say, for example, I want to system.out.println here, t1 dot times, say, 3 equals to plus t1 dot times of 3. And the same thing I'm going to copy. This is supposed to be double quotes. I have been doing Python and JavaScript in the weekdays, so I get that single quotes from there. So I'm going to copy this once more and then type here t2 dot times. And this is t2 dot times. So what do I have to do here now? So if you try here, member into num, this will not work because operator star cannot be applied to t and an integer. So you'll have to consider what actually the data type of this. So one way to do this would be I can say here integer dot value of member dot toString. So you convert that into a toString and then do that. But then it will also say that returns a string representation in this case, because this toString is that. This is an integer. Let's just return just a function, nothing else. Let's just type here public t get without this value. So let's keep it simple for now. And we're going to return basically member. Okay, so we'll not complicate things right now. So obviously I don't have this function. Let's call this as get. So this is get, this is get. There's no parameter. No parameter also passed over here. So this is T1 and T1. So if I try to run this now, you can see the first one returns a string. It doesn't show here though, but let me just try running this. When I say here, in fact, we can do something like this. Let's try x equals to t1 dot get, and you can see that the x returns here, the x is the return value from t1 dot get. If I press control 1 and say command 1, create a local variable x, you can see that it's creating string. Whereas if I say here y equals to t2 dot get, and this time it will create an integer because y, the t2 dot get returns an integer. So even though I said t here, because t1 is an integer string here, t2 is made up of integer. And then I can print here s out x equals to, let's use a printf, x equals to percentage s, y equals to percentage s, percentage n, and then I'll type here x and y. So when we run this, you will see that I am able to customize the object to some other type and then get the output. X equals to Vinod, y equals to 123. So we get that. So it's a very basic example. It doesn't do much, but that is what is actually going to be used in our collection framework. Okay. So we can have multiple types also. That means I can have here, instead of one single t, I can have two variables if I want. Okay. I can have two variables whenever I want. So 2, 3, as many as you want. So for example, if I go to the array list here, You can see that the array list is, it uses generics here. If you look at this array list here, it uses element, E for element that's using. And every time you are trying to add, for example, add an element, you can see that it receives an element and it's adding that element to by calling another function here. So if I go to the add function over here, you can see that it's checking. All it's doing is it is storing that in the E is the element that we passed. It is storing in that array. So internally, it is just an array of something, array of string or array of integer, depending on what I want, right? So very useful concept called generics. And let's try now using this in our, in the form of our array list and vectors, etc. So I'm going to take an example here called a list demo.java under programs. I'll add a main function over here. And here I want to create a list, and list from util, I'll say list of string. Let's call it as names equals to new. Now you can see when I type new, IntelliJ gives a list of suggestions, and it is giving in the order of most popular ones. You know, these softwares collect what is called they collect usage data, right? So the IntelliJ is taking all your inputs and say what is that people generally use, and it is feeding that back to me and saying that, hey, ArrayList is the most commonly used one. So I'm going to say ArrayList like this, and now I can start adding names.add, and let's say Vinod, names.add, say Kushal, names.add, say Naveen, names.add another Vinod, names.add, let's say Vishal, names.add, say Ram, maybe Ramesh. Now if I just say here s out, maybe you can say size of names is plus names.size, and that will give you that there are 6 elements in that, right? And I can say I can also print them if I want. So I can just use the names like this. So that actually prints that. So let's try running this. Right, you can see that we got a size of names is 6. I can, because it is an array list, or a list is index based operations. So which means I can say here names.add at index 0, add say Sham, and then you print the values. So let's copy and paste over here, run this. So at index 0, it is added. So Sham is added before that. If I want to add after we know some other names, so I can say here names.add. But if I simply add a names.add, it will always add at the end, okay? And let's say, for example, I want to add index 2 and say Kishore. And let's try printing this once more. Run this. And you can see Kishore is added after Vinod. So I can pick up an element. What if I add an element which is not the right index? 22 is an invalid index, right? There are hardly 6, 7, 8. 7 are there. When I'm adding this, there are 7 elements exist. So at the max, the index would be 6, I suppose. Let me check. But this one will give an exception called index bound out of bounds exception. You remember the array index out of bounds exception? This is the parent for array index out of bounds exception. So index out of bounds exception. If I give 7, 7 is a new element, and no problem. You can see I added at the 7th one. So 6 is the 7 elements exist. So 6 is the maximum index that we have, but I can still add at the 7th index. That is still a valid one, right? So every time I insert, you can see that the rest of the elements will be pushed. For example, when I added, let's copy and paste over here and make this as 2 and change this to say Kiran. 2 is going to be added right in between, which means what? Kushal should take Navin's place, but Navin should take Vinod's place. Vinod should take Vishal's. So Vishal should take Ramesh. Ramesh should take Kishore's place, and Kishore should be moved first outside that, right? So that is why arrays take more time for this one. Linked list is better in this case because linked list is just going to break the link between these two and then adds the new one right there, makes Vinod point to that new node points to Kushal, and that is done. So performance wise, inserting an element in between array list is slower than the linked list. I added, but I didn't print. So copy and paste over here. So to check. All right, so it's added over here, pushing every other element one after the other. So just give me 1 minute. Okay, so we are able to insert. Now, what if I change this from array list to linked list and remove the array list from the imports? Note that none of my code needs to change because I'm not using a linked list variable. You remember the polymorphism that we were doing? Animal A equals to new lion, new cat, etc. None of these functions are specific to linked list or array list. So that is the reason we always declare variables of an interface. Now, typically these variables will be found in parameters or the return data types. So those return data types and parameter types always are going to be interfaces or and inside the function you might be working with actually the classes. But otherwise, you see my code doesn't have to change if I'm changing from linked list to vector to stack, none of them. So the entire code works exactly like this, even if I change it like this now. So let's try running this. Now it's vector, and you can see that it's going to work just like that. No problems. For naked eye, this may not look much big difference in terms of performance, but if you're running some profilers, you will be able to see those changes. Okay. All right. So any questions you have, let me know, guys, about this so far. Okay. What we'll do now, it's 11:11. So let's take a 20-minute break, come back by, say, 11:30, and then continue with the remaining ones. And I'll also show you there are so many other interfaces and classes exist in the collection framework that will consume the rest of the day. Okay. And then I will show you how do you build something called the DAO layer, because we know JDBC, we will be finishing with the collections. In the afternoon, I'll show you how do you work with this layered applications. Okay. All right. So let's take a break for 20 minutes, come back by 11:30. Hey guys, welcome back. Let's continue with any questions you have. If you don't have questions, then I'll continue with the set. All right. So the set we can have either hash set, linked hash set, or tree set. So there is another data structure called as a map. So there's a collection called map. Let's put that right below here. So there's a collection called map. An interface called map, and which takes a key and a value uh, as parameters. Whereas here, they all take one single element's data type. Here it takes key and value data type. So the interface is implemented by many different implementations. One of them is called hash map. Okay. And another one is called linked hash map. So then there is one called hash set. Hash table. My mistake. So there's a hash table. So hash table was an older implementation in the version 1.0. Hash table also has a subtype called properties, which is very popularly used. That happens to be a extent. Okay. So hash map is based on a data structure concept called as hash table, which was actually the name that was given to the original class in version 1.0. So if I go here and look for hash table java.util, it was version 1.0 when it was introduced. It extends the dictionary that I mentioned earlier, but later it was rewritten in version 1.2 to implement the map interface, and they adjusted all the functionalities accordingly. So retrospected. So the reason I'm talking about this is because if you look at the concept of hash tables in Wikipedia, so let's say, for example, wiki plus hash table, if you look at that, you will see that the hash table is a data structure which accepts a key and stores a value in accordingly. So a picture here explains very well. So imagine I want to store the phone number for every person, maybe a friend or an employee. So there's a phone number on the right side, and the left side is the name. So internally we have an array called buckets. So here the bucket is supposed to contain the values, which are the phone numbers. And but how do I come to the index 1 or index 2 or index 14? How do I come to that? In this case, the bucket size is 16. The bucket size can go to say 256 and stuff like that, 512, depending on your requirement. So in order to arrive at the index 01 or 02, etc., it will take the key. In this case, the key happens to be the name of the person, and converts this into an equivalent index value, which is a number between 0 to 16. In this example, it's 0 to 16. Okay. So that's basically the hash function's responsibility. So there is a function that transforms given key into an index such that index is between 0 and 16. What if you have 20 names? What if you have 30 names? How will you store that, right? For a moment, let's forget that and assume that every name that I give as a key uniquely generates a hash number, which becomes an index. Like John Smith has become 2, Lisa Smith has become 1, Sandra D becomes 14 in this particular picture. But that's not reality, because what if I have more number of phone numbers to be stored than 16? You may say, okay, increase the number of buckets to 255. What if I have 2,500 people? What if I have 20,000 people? Would you like to increase the bucket size in that fashion? That is not the solution. So let's see what happens in case, given in this scenario itself. What if two keys generate the same hash number, same index. Because I don't want to increase the bucket size, but I have more number of people. Obviously, the hash function should generate a number between 0 to the upper limit. And what if that hash function generates the same number for two of these keys? So that is explained with another picture here. If you come down, you can see here, this is called as a hash collision. Look at this picture. The bucket size is 256. So 0 to 255 are the indexes of the array. Now, if you consider this John Smith, the hash function generates a number called 152. And incidentally, Sandra D also is 152. So obviously, we both, the John Smith's number as well as Sandra D's number should be stored in the same index, which is not possible. So what do? You use another data structure, so which is a linked list here in this example. So the bucket stores not the actual phone number, but a linked list. Okay, linked list of mostly one element, but in case if there is a collision, like John Smith and Sandra D resulted in the same hash number 152. So obviously now 152 cannot store two values, but there is a linked list that stores. So the linked list is actually going to contain only one entry for John Smith, one entry for Sandra D. So the first entry here, John Smith. So when Sandra D's phone number is added, it goes to this and it says, okay, this particular cell is occupied, this element is occupied, but let me go and check, is this Sandra D? The answer is no, it is John Smith. So it is going to add another node here, Sandra D, and so on. So next time, if you try to add again Sandra D with another phone number, it comes here and checks that, okay, so 152 is occupied by something, but let's go and check, is that Sandra D? So it goes here and checks, is it Sandra D? No, it is not Sandra D. Then it goes to next element, is it Sandra D? The answer is yes. It updates the phone number. If that was not Sandra D, imagine if it's something like, let's say, Sandra Bullock. And the Sandra Bullock also is 152, comes here. So Sandra Bullock not equals to John Smith. So go to the next one, Sandra Bullock not equals to Sandra D. Then there is no next element, adds a new element, Sandra Bullock and her phone number. So that's how this is the keys, the key collision or the hash collision is resolved in this example. And you can go and check in few other stuffs also here if you want. Okay, how it is overflow of elements and stuff. So read through these documents. I searched by wiki plus hash table. So the first one, you will get that anyway. So search for that and let me know if you still have doubts on that. We can discuss about that. Okay. But why am I talking about that? Because the hash set behind the scene uses hash map. So hash set uses hash map. So if I go to the hash set, okay, you can see internally it uses a hash map to store that, where I'm only going to store the key, not the value at all. So that means every element that I'm adding is considered as a key, and key cannot be duplicate. So that is what actually is done in this map. So there cannot be duplicate keys. So a hash set uses hash map to store its values. So let's see how this is going to work. And the word hash here is also very significant. So let's see why in few minutes. Okay, I'm going to come here and then create a set demo. And there I'm going to add a new main function. I'll say set of, let's say integers. This time I'll take integers. I'll call it as numbers equals to new hash set. Okay. And notice when you're using generics, you cannot use primitives here. It has to be object types or the class types. So integer is a class, so we can use that. Int is not allowed. That is not allowed. It's supposed to be integer. And right now I'm going to use hash set. Okay. So I'll say numbers.add, let's say 12. And I'm going to copy, paste it few times and make some changes. This is going to be 124. This is going to be 543. And this is going to be 323. I've got here 4 12s and 3 other numbers, total 7. But if I just type here system.out.println, size of numbers is plus numbers.size. And that's going to say not 7, but going to say 5 or 4 rather. It's going to say 4 because there are only 4 distinct numbers in that. So what happened to the second 12? It is because it exists, it is ignored. It's not going to be added. to the collection at all. So this is ignored, this is ignored, this is ignored. Not going to overwrite because 12 is same as the new 12. So there is no need to take that extra effort of overwriting. So if I type here system.out.println numbers, you will be surprised to see the sequence in which you get the result. It says here 23, not even the first one, it's the last one. Does it mean is it in the descending order? No. 124 is the second number, which is not duplicate, second unique number. So obviously that is not there, right? So it's basically, it looks like random, but every time I run this, I'm going to get the same thing. And incidentally, if you are using Java 11, you also should get the same numbers, same output for this number, because this number that we are given here will be used for generating an index of an array called buckets. So how does that happen? You'll have to go deep in that source code, okay, which I don't want to do. I've explained that with the help of that Wikipedia page. Just see if you can explore in Java, how is it being done? Okay, how is the bucket created? Now, if you say here linked hash set instead of a hash set, okay, now you see that the sequence of insertion will be maintained while retrieving 12, 124, 543, 323. So we got no problems there, right? You can also say here tree set, and let's import tree set, run this. This time around, you will see that there will be a swap with this because that's going to be in ascending order. Okay, you can see that they are changed because that's in ascending order. So for example, if I type here 112, and that will be the second number now, no matter what, because it is in ascending order now, as you can see, because of the tree set. So let's go with the hash set again and not worry about the sequence, okay? But while this is working fine with respect to some set of numbers, you can't do index based operations over here. That is not allowed. You can't say give me the seventh element, because seventh element that you inserted may not be the seventh element when I retrieve, if you're using hash set. So you can't retrieve in index based operations are not there. But while this is working with numbers, this will work with strings also, no problem. You can check that out. It's going to work with strings as well. Okay, so let's try the same thing. So I have here list demo. I'm going to copy all these things, names.add, etc. And I'm going to come here and then say paste this. But what are names? Names is a set of string. Okay, and I'll say here names equals to new hash set. And if I print out the values here, say names, you will see that the output will be in random order, but it will ensure that there is no duplicates at least. For example, let's say I'm going to copy these two, paste right there itself. Okay, so I got two duplicates here, but the output will not be different. It's going to be the same thing, right? So because these two have been ignored, because they already exist, they have been ignored. No additions. Okay, so while this is all good, will it work with my custom class? So I'm going to create a new package here now called say model, and I'm going to create a class called, let's say, employee. Easy to understand. You're all employees now. So I don't want to use Lombok for a specific reason. So first I will create here private int ID, private string name, private double salary. Let's say we will also give, what else we can give here? Let's just give like this, right? This is good enough, 3 of them. I'll have a default constructor here, so I can use command dot. No, I think I'll have to use, forget the shortcuts over here. Code, right click, generate constructor, select none and add one default. That's a default. I'll add another command N. Okay, so all of them put together. I'll add a getters and setters similarly. So command N, getters and setter. So for all the 3 fields, and we got all of them. I'll also add a two strings so we can get the output. We can just print them. So I got here employee with these many, I know this ID, name, salary, etc. So I got all these values. Let's go create a set demo. In the set demo itself, we can try. So because this is about say set of employees I want to create. So what I'll do is I'll say here set of employees this time, and employees from my own model package called employees equals to new hash set of employees, right? So new hash set. And I want to add a couple of employees over here. So I'll add here, I can add using directly set.add new employee, but what I'll do is I'll just create here employee E or EMP. EMP equals to new employee, and then I'm going to add here a few names. Let's say the ID 1122, then we'll take the name as say Vishal, name say salary of say 45,000. That's one employee, and then I'll say here employees.add EMP. And now I can copy this and then paste it few times, but with the different values. Let's give here 2122, say here Ramesh, 45,000 to say 35,000. I'll add one more, and let's say 7822. So Naveen, salary is let's say 45,500, 600 probably. Add one more, and say Neeraj, and this is going to be say 55 or 65,000. One last I want to add, and then I'll add some duplicates. So this one is going to be 7833. So Nishchal, and let's say this is going to be say 35,000 and 500, 600. I want to add a couple of duplicates. I'll just copy this and then paste right here. So I've added duplicate. Now you might be wondering why couldn't I add it directly here? I'll show you that in a minute. Now note that these three are duplicates. We know that, right? So Ramesh, Naveen, and Neeraj, they already exist with the exact same data. Employee ID, name, salary, all of them are a match. So now I have added those. I want to print all of them. And in order to print, I don't want to just print it using system.out.println. I can loop over this. How do I loop over? I can loop in a couple of ways. One, you can say for each. Basically, the syntax is for one employee called E in employees. So this is a loop that actually goes through the entire collection, gives me one at a time, and I can just do whatever I want. I'll simply say print that, nothing else, no fancy stuff. Okay, so now if I try to run this one, you will see that I think I added around 8 employees. 3 of them are duplicates, so I should get 5 ideally speaking, but let's have a look at that. Now you can see that I get all 8 of them, all 8 of them back. While I was hoping that these are duplicates, they're not supposed to come. That didn't happen. So why so? This is where you need to understand that in order to consider every time you're adding the employee object will be checked with each and every other employee's hash code. So that is something that is we haven't written so far. So the add function checks the hash code of employee with the hash code of all other employees. If that is a match, then it will check while the hash code matched fine, are they equal to each other? You know, if the hash code is same, coincidentally, imagine hash code happens to be same thing for like, you know, some coincidence. Then it will check, are they equal? If they are not equal, then only it will consider it as a unique object and it will add it. But if any one of them hash code is same and equals returns true, then it will consider it as a duplicate. But the reason why it is not working as expected is in the employee.java, we don't have any hash code and equals function. But as you know that every class inherit from java.lang.object, and java.lang.object consists of or has a function called hash code and equal, has 2 functions. So if I go to the object from java.lang, and you can see that there is a function called hash code. It's written in C++, so we don't get the code But basically, it gives you the starting address. Whenever an object is created, what is its address? It will give you that in a numerical format, that's all. But then there is also another function called equals, which will always return whether the references of two objects are same. Now, obviously, every time I create a new employee, it's a different object and its reference cannot be same as the other one, isn't it? So that is the reason for every object it will be false. They are unequal objects, it says, because the references are different, so it's not going to give you that value. So because of this, now this is always a false, and hash code is always different because that's the starting address of the or original address of that object, which will be always different. So what we have to do in order for us to consider that this is basically a duplicate. These are duplicates. Like this one, for example, is a duplicate of this, duplicate of this. Okay. We want to consider that this and that are two duplicate functions. What we have to do is we have to write return equals if the ID of this is same as ID of this, name of this is same of name of this, and salary of this object is same as salary of object this. Now, whenever there is an ID, you can just compare that with ID. You don't have to really compare anything else. For example, here it could be Ramesh, it could be Ramesh Rao here, and here it could be 35,000, it could be 75,000 here, because it's the same employee, but it's a different value. That is okay. But again, it's your choice. What you want to do is up to you, okay? So now what we do is we go to the employee.java and generate two functions. One is called hashcode, one is called equals. Now you have to override that. But instead of me overriding that, we can simply generate that equals and hashcode from this IntelliJ. So when I press enter, IntelliJ has couple of logic, couple of templates here. One, it says IntelliJ default. I'm going to select that. There's also one, util objects.equals and hashcode Java 7 plus. I think this is also okay. This was the first one selected anyway. Accept subclasses as parameters to equals, etc. So giving something. I don't have any subclass, no problem. Use getters during code generation. Yes, I don't want you to access the members directly. Use the getters. Otherwise, it will directly access the members. That is also should be okay. Anyway, when you do that, these are the three members. It says we will compare. That means if employee 1 and employee 2 are two objects, do you want to compare all the three of them are only ID? So if it's only ID, then untick these two. If it is all of them, let's select all of them. So in other words, we are saying that two employees are considered as equal if the ID of both the employees, name of both the employees, and salary of both the employees are identical. As well, to generate the hash code will be a combination of ID, name, and salary put together. So I'm going to say next, and that's fine. I think not null fields. We'll also say non-null fields. What if name is null, right? So I'll say finish. Now you see some logic that got generated over here. Okay. And there is a objects is a utility class that has a function called hash, where we can supply as many parameters as possible as we want, and it generates one hash code number. So a simple logic is there to generate. So now if I go and run this program, you see that this is equals to this object in all fields, and the hash code of that is dependent on these three. Hash code of this is generated based on these three numbers. So because their hash codes are generated from the same source numbers, so same source values, they will generate the same thing. So there is no problem. So for example, if I go to terminal and let's look at J shell, and then we're going to say import java.util.objects, and it is imported. Now I can say objects.hash of 2122 Ramesh and 35,000. So this number, no matter how many times I call, returns the same value, isn't it? So even for the first object, it is the same. For the second object, it is the same thing, right? So for this object also, the hash code will be exactly same. And for this also, the hash code is exactly same. So we have no problem over there. So whereas if I supply even a slightly different value, let's say, for example, instead of 35,000, it is 35,001. And instantly you can see that the hash code is a different one. I think it is reduced by one coincidentally. Let's say, for example, instead of 35,000, it is 45,000. And you can see it's a number. I think it is this plus 10,000 probably. I don't know. Looks similar, but anyway, they're different. That's all what matters, right? So, but as long as it's the same values, you will always get the same hashed number back. So that is basically how this is now working. But if I go and run the code, you will not see the last three outputs. There'll be only 5 employees, not 8 employees. You can see that, right? Because hash code and equals are implementing this. So let me know, guys, if you have any question. What is the significance of hash code or equals? If somebody asks you, you should now tell that in case of data structures like hash set, hash table, hash map, linked hash set, linked hash table, in all these, whenever you're trying to add an object, it is going to check whether the hash code of the two objects, hash code of the object being added is compared with the hash code of all other objects in the in the collection. And if they are same, then it's going to check, are they equals? If they're not equals, then it doesn't matter, isn't it? Even if the hash code is coincidentally same, they are not equals. So that is the reason why that's the reason why it is supposed to be. I want to check one more thing here. See, hash code, the why it will be same. So if I use the same concept here, let us say I type, say, Vinod, Kumar, and this is the hash code value. But what if I have here KUM is here, a KU, and now you can see that the values are different, even though it is not just a concatenation. But if my logic for generating the hash code was like, okay, concatenate both first name and last name and then generate the hash code, then it would have been Vinod Kumar here also, Vinod Kumar here also. So, but in this case, it's doing a different approach. That's why the hash code is generating different results. But in case if my logic was like concatenate these two and generate the hash code, then the hash code would be different. Hash code would be same for two set of values, but they are not equals because first name is different than the first names are different, last names are different. Equals would be false. That's why don't just depend on hash code, depend on equals also. So apart from this, the hash code and equals have absolutely no other usage in Java. I've never come. Equals, at least we can check. They will be used in many places, but not the hash code. So the use of hash code is only in data structures like hash code, hash table, hash map, hash set, linked hash set, linked hash map. All right. So I hope no questions are there. Oh, okay. While this is all fine, now note that I'm going to change this to tree set instead of hash set. We tried this earlier, but let's enter tree set and let's copy the same thing to the strings also. And I'm going to run this. And when I run this, you can see that this is in ascending order. This is in alphabetical order, right? VIN is different than VIS. So N has a smaller value than S. So Vinod is alphabetically smaller than Vishal. And similarly, the other ones, right? But let's say I have 5 different employees. When I print, I want them to be in ascending order. But when you say, how do I sort the employees in ascending order? So what is that? Do you want to sort them by ID, or do you want to sort them by name, or do you want to sort them by salary? How exactly this is going to work? Let's find out. So I'm going to just give the tree set even here also. So I'll copy tree set, paste over here, and remove the unused import. So when I do a tree set, remember it's a binary search tree, balanced binary search tree called red black tree. And in a binary search tree, it is supposed to take this employee and check, is this smaller than the root element? Then I will go on the left side, otherwise I'll go on the right side. But there is no root element, this becomes the first one. The second time when I add, how do I consider the employee here? The employee, let's say this is employee 2 and the other one is employee 1. So this has to be compared with the root element. So the root element, it has to check, is this employee smaller than the root element, which is another employee? But how can we compare two employees? Can I say emp1 less than emp2? Will it give true or false? The answer is no. The less than operator cannot be used with employee objects or any custom object for that matter. There's no operator overloading in Java. So then, obviously, since we don't have any natural ordering between employees, the tree set cannot organize them into left, right kind of stuff. So the tree set will fail when you're trying to add the employee here because we cannot compare an employee with another one. So have a look at the error that you're going to get. All right, so you can see that this worked, but then I have an error. It says class cast exception. So the class being cast is an exception. The employee cannot be cast to a comparable. So basically it says I cannot treat an employee object as a comparable object. I cannot compare one employee with another employee. That is what actually it is suggesting. So in order to make this as a comparable object, all you have to do is to implement the interface comparable in the employee.java. So if employee class implements comparable, then an employee object is a comparable object. So we'll go to the employee.java and then go to the beginning, add here implements comparable. When you say comparable, what are you going to compare one employee with? Are you going to compare an employee with a number? Are you going to compare an employee with a string? What is that? We say that one employee is supposed to be compared with another employee. And it still says an error because the comparable is an interface which forces you to write a minimum of one function. You can override minimum of one function here, where if I go to the quick fix, it says implement the abstract methods in the comparator. I'm sorry, I think I wrote wrong. This is supposed to be comparable, not comparators. We'll come to the comparator also, employee. And so this is from java.lang, so no need to import anything. It says here comparable is supposed to, comparable provides one abstract function, and it says that implement that method. And it says the function is called compare to. The function is called compare to. So we want to implement this, and its return value is an integer. So we take another employee object and then we have to return an integer. What is that integer? The integer is supposed to be a negative, positive, or 0. 0 means the employee, this because it's a member function to be called by an object. So this object dot, this object is exactly same as the other object that we receive over here. Let's just rename this as other. Okay. So this dot ID is same as other ID. This dot name is same as the other dot name. This dot salary is same as the other dot salary. So because all the three of them are same, then this employee is same as the other employee. So that's what we'll have to return 0. If this employee is smaller than the other employee, return negative value. If this employee is bigger than or greater than the other employee, return positive value. But what is the meaning of less than and greater than, right? Now, this is where we want to take natural ordering should be based on something like ID, for example. If two employees have the exact same ID, then I want to consider that as it's a duplicate employee. So we're going to come here and type return. Okay, I can, because integer minus integer will give you 0. But its ID cannot be accessed from outside. So you can't say just ID here. That would be also okay because we are inside a class, so that should be okay. But get functions are better. Now notice that it's purely based on ID. So if I now go here and then check, that's a tree set that we are adding to. So tree set knows that this employee is 1122 and it has got a natural ordering. So there is no root element it will add. When we add this one now, 2122 less than 1122 because we are only comparing ID in the comparable here now, right? So this is like 2122 minus whatever the other number, So we get a negative, basically it determines whether it should go on the right or left, depending on whether you got a negative, positive, or zero. So in this case, 2122 minus 1122 is positive. So positive means this is greater than the other one. So this will go on the right side. This will go on the right side. This will go on the left side of the previous one. So likewise, it's going to determine. So let's go try running this now and see that there is no error this time. Plus, the list will be displayed in ascending order of the ID. Ascending order of ID. So the proper way of doing this is not by returning this, although this is perfectly all right. The better way to do would be to say integer dot compare two numbers, which is this dot id and other dot id. So the integer has a function called compare. That's a utility function. It takes two parameters, returns 0, negative, or positive, depending on that. But if you actually go there, they also probably might be doing exactly same. You can see, or they're returning like this one in a condition, so either a -1 or a 1 or 0. If they're identical, they're basically using a nested ternary operator to do the same thing. They're returning, basically this is returning -1, 1, and 0. Whereas I earlier sent some random minus, positive, minus, plus, and 0 based on the difference, right? Either way, it works fine. There is no problem. If you run this, it's going to run without a problem. You can see that it's working. But it's natural ordering. So if you just say that, hey, these are the employees, sort them, by default, it's going to use ID as the sorting criteria. Okay. Okay. Let me know, guys, if you have any questions. If you don't have question, then I think I want to take some 10 minutes break. And then I'll come back, continue with how can I say that for this, I want this to be ordered by ID, but another set I want to create employees too, where I want that to be ordered by name or ordered by salary. So I want to determine that as well. So how do we do that? We'll check. Okay. But if you have a question, feel free to ask. If you don't have a question, then I want to take a 10 minutes break. All right. Looks like I'm talking to myself. Let's take 10 minutes break and come back at 12:20. Okay. Any questions? No questions? All right. So let's move on. We have here a set of employees, and the reason I typed like this earlier separately is to show you what is the hash code of each of the employee. So I want to just type here emp.hashcode. That's the number, and I'm going to copy this, paste in each of these lines. And note that when you're using tree set, hash code is of no use. Okay, hash code equals are of no use. This is the, if I type here hash set, okay, and now that I have a hash code and equals, so let's say, for example, I want to comment these lines, these two equals and hash code, I want to comment, okay, and I run this, you will see that all of them will have different hash code values. So the second one here, Ramesh, I think this might be Ramesh, I may want to print along with that. And you can see that they all have different values, right? But if I go and uncomment this over in the employee.java, that's an uncomment, and run this, you will see that two of them are two Ramesh and two Naveen, etc. will be of the same ID. You can see that this one and this one, right? It's the same thing. And there is also one more, for example, which one is that? I have to find out. This one, 24, ending with 2424. And there's one more, this one, ending with 818. So they are duplicates, and the duplicates are ignored because now you have this one, right? So when you don't have the hash code and equals, it is inherited from the object.java or object class. And in the object class, it's just the address that it gives you. So obviously you will see that in a I mean, every object, even though their content is same, the hash code would be different. So we want to ensure that the content, if the content is same, hash code should be same. So that's the whole idea here. So if the content of two objects are identical, they must have same or identical hash code. Okay, that is the meaning of that. And same thing happens here. If the contents of the two objects are identical, return true, else false. So if the content of two objects are identical, return true, else return false. Okay, and that is what actually is the meaning of this one. Anyway, let's do one more. I want to be able to create different tree sets. So what I'll do is I'll just copy this. I'll make some quick alterations because it's too big. So I'm going to create another Java class here called, not here, but under programs, called comparator demo. Then I'll add a main function, and then I'll paste all these. I don't need those print statements. And what I can do is I can add this directly in here instead of that. I don't need the hash code. I don't need this employee object. I don't need this. Okay, I'm just going to do a quick adding. And it doesn't matter whether I have the duplicate or not. Okay, so let's get rid of this. So notice that when I add elements to the tree set, I want to use tree set this time. But when I get the value, it is getting by default in order of employee ID. Also, it ensures that there are no duplicates. But I want to be able to decide, what is the ordering based on? Is it based on ID? Anyway, that's the natural ordering. But is it based on name? Is it based on salary, etc.? Let's go and change this to tree set and remove the unused import. So let's try to run this. Ordered based on ID, right? But how about creating this object, this employees? But I want to ensure that it is based on the names, not based on the ID. Now you may say, okay, let's go to the employee.java and then change the natural ordering. So this provides basically natural ordering here, right? So I can say here that this provides natural ordering to employees. Okay, so natural ordering, like how numbers have natural ordering, isn't it? So I can go and do that, change that logic inside the compare to function, and instead of comparing ID, I can compare names. But then what if that employee.java is not yours and you only have the .class file? You don't have the ability to, or the permission to change the source code, right? So there has to be a different mechanism. And that is where you have an interface called comparator. So comparator, I think I typed comparator from basically java.util. Okay, java.util. And when you see here, there are a couple of things that you can see. Number one, it says functional interface, something that is interesting. We'll discuss about that as soon as this example is done. The comparator has got many functions, but out of which there is only one abstract function, which is this one. Now, if you are surprised to say, hey, it is an interface, isn't it that all the functions are abstract? Now, in Java 8, they introduced a concept where a function in an interface can also have bodies. But most of the time, those are limited to throw some exceptions or do some basic stuff, and they are called default functions. As you can see that except this compare and this one, because this is there in every object, isn't it? Every object has a equals function. So don't worry about this. This is as if non-existent function. But except this compare, every other function has a keyword called default. That means there is a body there. You can see that they're not abstract functions. So it is not mandatory for you to override. But if you want, you can override. Right? There is a default method body given for that. You cannot create an object of this interface directly and call these functions like classes, but the implementing class will have this function inherited, so you don't have to write that. Now, why did they introduce this concept? I will explain probably a bit later, but the idea is that you don't have to really write anything. If you imagine you have a class that was written when Java version 7 was there, and that implements this comparator. Now, if they did not make this as default, they added additional abstract functions, then all the older programs have to be modified because now they introduced a new function in the comparator. That becomes a big deal, isn't it? So millions of Java classes would have, in the world, in millions of projects, millions of Java classes would have implemented this comparator. All of them have to be rewritten if they provided more abstract functions over there. That is why they said, okay, let us not touch the old code. The old code, in case, will still continue to work with this comparator, but newer ones can have these functions overridden. So essentially for me, if I write a class that implements this comparator, I have to write this function. So to demonstrate that, what I'll do, I'll just go here and then create a static class called, let us say, for example, employee name comparator. Okay. which compares, which implements comparator of, I think it's supposed to compare two employees, okay, and just leave it like this. So obviously the class is giving an error because we are implementing an interface with one abstract function in it. And what are we supposed to do is we are supposed to implement the unimplemented or abstract functions. And we are forced to write only one of them, which is called compare to. While all these are there, they all are having the default body, so we don't need to. So we just write this one. Any other function you write and not this one, you will still have the error, because this is the only abstract function that is there. What I want to do is, if there are two employees are given, let's say for example, M1 and M2, assume that I have two employees, M1 and M2. I want to return again 0, negative, positive, depending on the name. And because these are basically based on name, I want to compare the name of M1 and name of M2 and return an integer. We have a class called string.compare. I think we don't have here, isn't it? String.compare is not there. So what I can do is, string itself has a compare function. So I can say here M1.getName, compare that with M2.getName. So we are comparing the name of M1 with name of M2. And this comparative function is coming from string.java. If I go there, you can see it is the string.java that returns an integer which is negative, 0, positive, depending on whether first name is, this name is less than this, then you're going to get a negative number. If this name is same as this number, then you're going to get a positive number. Sorry, same as means 0. If this is bigger than, greater than this one alphabetically, then you get a positive number. So now we have a class that implements this comparator. And I can supply an object of this employee name comparator as an argument here. So I can say a new employee name comparator as an argument. So by default, the tree set did not take any comparator. So it took the help of employee.java itself and took its natural ordering and ordered based on ID. Now the ordering is based on this. Now this is basically where we are supplying a strategy, right? Supplying a strategy of how to compare two employees and determine which employee is small, which employee is big. And this pattern is called, this kind of a solution that you give is called as a strategy design pattern. We will spend some time in understanding some of the design patterns, but here you can see we are supplying a logic. Earlier, this was making use of the logic in the employee.java as which employee is small, which employee is big. Now we are supplying only that logic part here. And that logic is actually taking two employees and comparing one with another one. So if I try to run this one now, you will see that the list will be ordered based on the name of the employee. So NA is before NE because A is smaller than E and E is smaller than I. N is smaller than R is smaller than V, right? So Vishal. So that is how it is working, okay? So it is now alphabetically sorted. What if I wanted in reverse order? Change this from M2 to M1 and vice versa. And if you run this now, it's going to be in the reverse order, right? So Vishal, Ramesh, Nishchal, Neeraj, and Naveen. So I'll keep it as this itself, okay? So you can create an object of a class and then supply. So I can simplify this also. Instead of doing all these things, I can create, see, the whole idea of this class is to create one object like this. So in its entire lifetime, you will have a single object of that. I'll never use this anywhere else, isn't it? So why do I need to create a class? Why can't I just create an object? So this is where we have something. So what I'm going to do is I'm going to just copy this line, comment it out, okay, and paste again. So this is for your reference I have here. Now in here, what I can do is I can simply say, hey, I want a new comparator. New comparator. I want an object of this entire stuff, new comparator of employee. So employee type, and I will call the constructor. But then you may say, okay, comparator is an interface. How can I create an object? I cannot. You're with me on this, guys? Important cool features here, okay? So you cannot create an object of this interface, but I can put a curly bracket here. And when I put a curly bracket here, see, if I don't put this curly bracket, the error message says something. Look at this problems here. It says comparator is abstract, cannot be instantiated. But if I go and put a curly bracket here, now you see it says class anonymous class derived from comparator must either be declared abstract or implement abstract method. So the error message went different, isn't it? So what is happening right now, if you carefully observe, is this is a class. This curly bracket is a class that implements this interface, and we are creating a new object of this class. What is the name of the class? No name. So it is anonymous. So hence, we are creating an anonymous object here. An object of anonymous class is object. It's an anonymous object. So we're creating an anonymous object here. So the error says that this class must implement the abstract function. So if I go here and click on these implement methods, which are abstract, the only abstract is this compare. So if I say, okay, you can see that now I got this function. So I don't need this override. Let me get rid of this to keep it small, okay? So you can see here, I have an option where I can supply some values over here. Now, incidentally, I kept the salaries are all distinct. I did not keep, I didn't keep the same salary anywhere, I suppose. So I can now compare here two employee salaries. So let's say this is M1 and this is M2. What do I do here now? I want to compare M1.salary with M2.salary. And salary is a primitive double. It doesn't have any function. If you type here M1.getSalary, if you try to do compare, it doesn't work. But what I can do is there is a class called double that has a function called compare two doubles, like integer.compare we have. So similarly, we have M1.getSalary with M2.getSalary. So I have got two things. Now you see, while constructing the new tree set, I supply an object of comparator without creating a class. Now this may look big, but up to Java 7, this is what we used to do. Java 8 onwards, we can do things in a little bit different way. And just to check if this is working properly, I'm going to go here and then run this and ensure that the salaries are all in ascending order. So 35, 600, 45, 600, 65,000, all in ascending order of salary. I hope this is clear, guys. Let me know if you have any questions over here. I'm sure you should have some questions if you're watching this. Okay. Now, come Java 8, this is further simplified. So they introduced a concept called functional interface. You can see that this happens to be a functional interface. It doesn't have to be functional, written as functional interface, but it's just a notion saying that, hey, it's a functional interface. The meaning of functional interface means an interface with exactly one abstract function. Okay? Functional interface means exactly one single abstract method in an interface. So what I can do is I'm going to comment this again. So I'm going to copy and then comment it and then come back here and then paste it further. I'll modify. This is for your reference. So, okay, that's for your reference. But then anyway, this is going to be going through some changes now. So in Java 8, they introduced a concept of arrow functions along with this functional interface. Now, one thing is arrow functions can be used only with functional interface. What is a functional interface? An interface with exactly one abstract function. Okay, why is that restriction? I'll tell you now. See, if you want a programming language to work as a functional programming, paradigm, work with a functional programming, then you should be able to pass functions as arguments. You should be able to receive functions as arguments. And they are going to be very useful at some point in time, okay? And these functions are pure functions. What is a pure function? Anybody knows what is a pure function? Some common definitions here. Let's go to the README here. First is functional interface. An interface with exactly one abstract method, not zero, not more. It's exactly one abstract method, okay? What is a pure function? A pure function is a function or a method that takes parameter and work on it on the same and return a value, has no dependency on any other functions. Okay, has no dependency on any other functions. Okay, so it just takes one, like, private contractors. They take the input, they do the work, and they give the output. That their job is done. No dependency on anything else. Like me, for example, right? I'm not an employee of Target. I'm not an employee of any other company. I'm just a freelance. My job is to come on Saturday, take the class, and give some, whatever that my source code and stuff like that done. That's it. I don't have any dependency on the company Target. Like, for example, you guys have, say, TA, DA, basic salary, HRA and stuff like that. I don't have any such insurance. I don't have any such obligations or any such facilities from Target, right? So it's a pure function. So there is no dependency on any other functions. So coming back here, now, what we have here, functional programming is, can I pass the actual function instead of a new object? See, the whole reason why I'm creating an object is to pass that function. Why can't I pass function as an argument? Now, until up to Java 7, uh, you cannot treat a function as an object in Java. You cannot create see, in JavaScript, for example, a function is an object. I can add additional values to that. A function can take some additional values, and a function can have functions. Functions can maintain values as well. You can pass function as argument. You can return a function from a function as a return value. You couldn't do that in Java up to Java 7. But Java 8, they introduced the concept of arrow functions. How does it work? Number one, it works only uh, on functional interface. Now we know that comparator is a functional interface. So they said that, hey, instead of supplying this new object, so let's get rid of this part and let's get rid of this bracket. So we don't need this bracket. So we are supplying only the function here. Now that's giving an error. That's understandable. Just hold on for some time. I'll explain. So we are supplying a function in a wrong style. That's the reason we get an error. But I'll tell you, this is what we want. We want to supply a function, especially when the function has one-liners. In this case, the function has got one line. If the function has got like 10, 15 lines, there's no point in passing it to like this one, okay? But anyway, what we can do here is, now we say that the function here is supposed to be an implementation of comparator, because if you look at the tree set arguments, what are the tree set? Let's go to the tree set.java, tree set constructor. Let's go to this. Okay, I don't know why it's not going. Let's open tree set. Okay, and if you look at the constructors, there are one constructor that takes a no argument, takes a collection as another argument, and we know that this is not a collection, it's a function. And there is another map we can supply. It is again something else. There is another sorted set I can supply, but this is the one, which is a matching type, comparator. So it says that, okay, whatever that you're passing here is a function belonging to the comparator. But comparator has got many functions, but which is the abstract function? We say that this is the body for the abstract function. So because of which, we don't need to give all these extra decorations over here. So we don't need to say public int compare. We don't need to declare these employee and all, but basically we simply have to give an arrow here. Arrow is like this. Now you see, I don't have any error. So we are giving the function's body here, which represents the function in the comparator. But how does it work? I didn't mention here what is the return type, what is the name, etc. This is the method implementation for the only abstract function which we have in comparator. That is why this works only on the functional interfaces. Now you know that the only function in that takes employee object and not any other object. It doesn't work with any other object. So I can just give like this one and still no problem. You can see that I give only variables. Okay, automatically assumes that because I'm using a set of employee here, it will borrow the data type from there, M1 and M2. So this is an employee object, another employee object, and we are returning, this is the body of this. Now, if the body of the function is only one line, you don't need the curly bracket and the return statement also, which means I can put this in place of the whole curly bracket pair here. Now you can see that my function is very, very simple. So I have parameters and I have a return value. That's it, simple, right? And also it looks very elegant also. It does not like so much. You can think of this one and compare that with this one. So we say that, hey, I'm passing a function which knows how to compare two employees. Take that and then compare and then sort. And we are using the salary here. So I should get the exact same output when I run this one. Right, so I got the exact same output. What if I want it in different order? So I can say employee 2 and make this as employee 1. So compare employee 2 and employee 1, and that is basically going to be in descending order of salary now. 65, 45, 6, 45, 35, 6, and 35, right? So we are able to supply whatever that we want in the form of just a pure function here. So these are also called as lambda expressions, but mostly we call it as arrow functions instead of lambda. These are the concept exists in almost all the languages that I know of. So like Python has this, JavaScript has this, C# has. So it represents the function arguments of the abstract function, and this is the return value from the function. So note that this emp1 is automatically considered as employee. For example, if I type here emp1 dot, you can see we get all the functions, get ID, get salary, etc. So I'm going to say get salary, and this is m2.get salary, just to make sure that it's ascending order. Any questions here about arrow functions, pure functions, functional interface, anything? All right, excellent. So this is very, very useful in many cases, okay? For example, let's go try here Java class. There is a utility class called collections, utility demo. And let's consider we have a function. We have a list of employees. We have this list here. Let's try to take this list of names. I go to the set. I have a set here. Okay, I think I'll take the comparator itself, this only. But I'm going to create this as a list. So I'll say here, list of employee, let's call it as employees equals to new array list. And then I'm going to add all of these. So add is a common function, so it is adding. This is duplicates allowed here. So just change the duplicates to something else. Let's say this is going to be 55. This is say Ramesh, for example, Iyer, or let's make this as Rajesh. This is going to be Nimesh. Let's give a different value here. So 98 and 72. So let's say here 77. And this is going to be Girija. Okay. And we have all these values. Okay, let's keep the salary. Or salaries anyway are different, but I think for Ramesh it's there. So 35, it doesn't matter. Okay, it's going to, if in this case, while sorting, I can say that hey, if these are same, it's okay. Anyway, we have here a class called collections from java.util. Now it is a utility class which has got a lot of functions. For example, I want to sort them. So how can I sort them? So I have a function called sort, and I can supply a list here, and that returns nothing. It's void. So I can say here employees. This is a list of employees before, before actually processing, and I want to print them. Now, how do we generally print? We print it with the for loop, isn't it? For employee E or EMP or maybe EMP in employees. Then we're going to say here sysout. Then we say employees, EMP, right? That's before. And let's just print here dot repeat of say 50. And then I'm going to copy and paste this part. Okay, so after sorting employees. Now note that the sort function by default needs two employees to be compared at a time. I hope you know how the sorting algorithm works. If you don't know, it is going to take two employees. Let's say it is using bubble sort, assume. So imagine it's using a bubble sort. So it takes the first two employees and then checks which one is greater, the first one greater than second one. If that is true, then it will swap. If the first one is not greater than second one, then it is not going to swap. Then it's going to take the second and third employees and then check the same thing. If the second employee is greater than the third employee, that's going to swap. And this process will continue for all the employees except the last one. And because last one anyway, it would have compared. So in one iteration, the biggest value goes down. Then again, it will start from the beginning again. Two employees are checked consecutively. And in the second iteration, second biggest element comes to the second bottom. And this is how it goes in the bubble sort, okay? Then once this is done, but in any case, in order to compare two employees, I need to compare, right? And if you remember in the employee.java, we have a natural ordering because of this comparable. So comparable has a function called compare to, and we have this natural ordering. So because of this now, our application is going to work just fine. It's going to sort and display the same, right? If you look at that, before this is the value randomly, but now we see 45. It's not. Oh yeah, sorry, ID. So 1122, 2122, 2155, 6726, 6777, 7822, 7833, and then you have the 9822. That's the biggest ID, right? So the natural ordering. But what if I want to sort them based on, let us say, for example, the name? This is where I can pass second parameter. So I'm just going to go comment this one and copy this, paste here, pass the second argument where I get E1 and E2, E1 and E2, which are two employees, and I would like to return zero, non-zero, zero, negative, positive, depending on which name is big. So what do you do here? You say here E1 dot get name dot compare to E2 dot get name. That's it. Now you see, we supply a logic. Basically, we are supplying a comparator here, a comparator object, but very elegantly in this case. So now that it is done, so I can go and check it out. The result should be based on alphabetical order. All right, so you can see Girija, Naveen, Neeraj, NA first, NE later, NI later, NIS is later than NIM. Then you have Rajesh, Ramesh, RA, J comes before M, then Vishal. So sorted. Likewise, if I want based on the salary now, I can just go here, just check the even dot, what is that I want to return here? I want to return basically double dot compare these two values, E1 dot get salary, E2 dot get salary. So we are comparing the salary, and that is what is happening over here in this case. So if I go back, run this, and now you should see that it is all ordered based on salary, 35,000, 35,000, two of them. That's because they are same, but it doesn't matter when they are same, isn't it? But if you think that no, if the salary is same, then you have to compare the name. That also you can do. Incidentally, it is Ramesh first, Rajesh later. I think it's supposed to be Rajesh and Ramesh. But don't worry about that. If you want to do, then you have to extend your logic. Okay, I'm not going to do that, but you can extend your logic over there. But 35, 600, 45, 45, 600, two of them, then 65,000 and 65,000, both Neeraj and Girija. So that's what is happening over there, right? Neeraj, 65, yeah. So that's perfectly all right now. If you want in descending order, change E1 and E2, swap the E1 and E2 here, that's all. So becomes very useful. Okay, becomes very useful in this scenario. So I hope it is clear about how these sets work, when to use or when to implement hashcode and equals, when to implement comparable, when to use comparator. You just have to answer these questions, okay? And then it will be very, very clear. Apart from that, we still have some more things to cover, a lot of things to cover, actually speaking. We have the hash, or rather we should say we have something called maps. This is the map we have over here, right? So we will cover a couple of them. We'll cover all of them. Let's see, how this goes. Apart from this, there is we covered a comparable comparator. There's something called iterable and iterator. So two objects that sometimes you work with. So we will cover all those things, but I think time to take a lunch break. But if you have questions, we'll have some more minutes. Anybody have some questions? All right. So if you guys don't have a question, then I think it's time to take lunch break. We'll come back after 1 hour. So come back 2 minutes before 2 o'clock so that we will all be there. Otherwise, again, I have to wait after two o'clock. So I don't want to wait after 2 o'clock. We'll cover some more aspects about this. Okay, collections. Today, everything is about collection. I also want to cover something on streams. It's really interesting and important that we work with streams. Okay. For example, the whole thing that I'm doing here can be simplified by just typing employees dot, you can say for each, employees dot for each, system dot out double colon println. Notice one single line replacing this whole for loop. So I'm going to copy this, comment this line, and paste it over here. So output is going to be exactly same, right? So how does that work, right? How does that work? Really, seriously, it looks like kind of strange syntax. We haven't seen this. Some of you have done this probably, but what we'll do is we'll take a break for lunch now and then come back and look into all these magical stuff because of the arrow functions. Okay, we call it as streams. We look into that. So let's take a break. Come back by 2 o'clock. I'll be outside the meeting and rejoin at 2 o'clock. Okay, welcome back, everybody. So, not everybody is here, but we'll start. So, we have seen comparator, comparable, hash code equals, which are useful when you're working with different types of collections. So, let's have a look at a map. A map is a basically key value based collection. So, that means unlike the array list, which has index-based operations, unless the list which has got index-based operations, set which has got, we can iterate because collection, the collection interface inherits from something called iterable. So iterable, and let's also add a arrow here. So that's inherits from there. So collection inherits iterable. Because it is an iterable, we can iterate over. So if you look at iterable, you can see that there is a function called for each. This is actually a default one that was introduced in version 1.8. So you can loop over. But basically, you can get an object of something called iterator. Every iterable will have some function called iterator. So I can go here and then get the iterator here. So let's say, for example, let's copy this and paste over here, one line gap. So I can say here, employees.iterator. When I get this, let's say, for example, IT equals to, and IT is an object of something called iterator. So this function is going to be there in every type of collection, whether it is a list or set or queue, stack, whatever you have, it will be there. So what can I do with this one? So if you go to the iterator, this is a variant of something called enumeration. So if you go to the iterator here, you can probably see it allows you to iterate over a collection, takes place of the enumeration. Basically, enumeration was introduced in version 1. Iterator was introduced in version 1.2. It takes the place of enumeration in the Java collection framework. Iterators differ from enumeration in two ways. Number one, iterators allow the caller to remove elements from the underlying collection during the iteration. So that means you can mutate, you can delete an element from the collection. And method names have been improved. That's all. For example, if I want here now, I can say while it.hasNext, and you can say that it.next, which will give you an employee here. So if I create that variable, you can see it's an employee object. So this function returns true or false if there is any element, and also moves the cursor to the, just returns true or false. This one returns the current element, which is the first element, and then moves it to the next element. So when you go here, you can see that now the iterator has one less elements, and it's still true. So it enters, gets the next element, and then keep checking. And once you are coming out of that, so that means once it has iterated over the last element, the next will return false, and that is when while the loop will break. And in between, I would have probably printed out this, okay? And now it.hasNext is false, so you are able to print. So if I go and run this, you'll see that there will be a third set of prints, which is basically the same thing. I'm looping over, okay? Uh, this is one way of looping over any collection, whether it is a list or set or queue. You can iterate over like this. Prior to this, there was something called enumeration. I think we did that enumeration in the previous last day with the JDBC. If you look at our code, we used one called get list all loaded JDBC driver. If you see, we use something called enumeration here because this function was written in version 1.0 itself. And that is the reason it is returning an enumeration. And using the enumeration, we have a function called has more elements. And then we say next element. So these two functions are improvised over here by saying has next and next. Earlier it used to be has more elements, next element. Here it is now has next and give me the next one. So it is a very similar one. Version 1.2 onwards, iterator became a kind of a standard. Now, you can also use a for loop like this, which is called for each loop. And for each loop basically can be used on anything that is iterable. So here it is an iterable, uh, and internally it uses this concept of looping over like this. Although there's a keyword, the language itself uses a similar feature there. So that's basically about iterable iterator, comparable comparator, and set and list. Now let's take a look at map. So I'm going to create a new Java class called map demo. Maps allow you to add an element with a key. So you can't just add an element. You have to associate an element with a key. For example, imagine I have all these things like this, right? I can probably say here, let's close these two, main. You can create a map. You have to specify what is the data type of the key. For example, if you are storing employees, typically it would be an employee ID, which is an integer. And then you will say that there is an employee is the actual value. So equals to hash map or hash set, depending on what you want. I didn't declare a variable here. Let's call it as employees equals to new hash map. So as I mentioned in my diagram here, there are different types of maps. One of the map is called hash map, and the other one is hash table. Now, hash table is called as legacy, just like the stack, because it was introduced in version 1.0, and many of the functions that mutate the data, they are synchronized. So if you go to the hash table, and look at the functions like put, for example, it is synchronized. If you look at the function called remove, that is synchronized. If you look at a function called get doesn't mutate, so it's not going to be synchronized. I think it is synchronized anyway here, but it doesn't, I don't know, it's not really required to be synchronized, but it's done. Similarly, you also have, I think these are the functions that mutate, okay? So they basically are all synchronized. If you look at the hash map, on the other hand, uh, they don't implement using synchronize. So for example, if I say put, you can see that put is not synchronized, get is not synchronized, remove is not synchronized. So none of the functions are synchronized. But here, the functionalities are same because they all are implementations of map. So what do we do here? So we say here employees.put. You need to give the employee ID and then probably create the employee object. So maybe I can say here this 1122 is the employee ID, and then we have an employee object. So likewise, I can take the second one. So 2122. So this is the one. And let's just do one thing. Let's copy all of them and change necessarily like this. Okay, so of course it's not put. See in here, I cannot do a lot of things. I can do that in VS Code easily. Let me just do that. So I've got all of them like this. All the add should become put. So I can just go here and then say put. And then I need the employee IDs as the first one. You can see here, so easy, right? Oops, sorry. So let's copy all these and put here. And now you can see I got all of them like that. At one shot, I'm able to do in VS Code. So simple. Anyway, so I got this employees created. All the employees are unique, but if you add a duplicate, for example, let's say I take this 7822, I paste over here, but let's say I change the salary to say, for example, say 55,000. Okay, and here it was 45,600. It's going to be 55,000 here. Same employee. But when you add, I have here how many? 4 plus 5, 9 employees. But if I type here, size of employees is plus, so employees dot size. Notice that map has no connection with the collection. There is no relationship between map and collection. but some functions are similar, like size. So you don't have an add function here. Instead of that, you have the put. Now, while I added 7 employees, there'll be nine employees. There'll be only 8 employees now. So if I try to run this, it's going to say that size is 8. Size is 8. But if I want a specific employee based on the ID, let's say that 7822 is the ID that I'm looking for. I can say here employees.get this number. The return value is one single employee and create that local variable. You can see that's an employee. And if I just type here EMP, that is going to be this value, not the old one. See, in case of a hash set, the repeated values will be ignored. Duplicate values will be ignored. In case of a map, the duplicate value will overwrite the existing value. So the old value is gone, the new value will be there. So that's basically, let's say, Naveen Kumar. And when I run this, it's going to tell that it's Naveen Kumar, not Naveen, right? So it's changed. So that's because it's overwritten, right? So that is how the maps work. You can also remove based on a key. For example, you can also check if there is a key exist or not. You can say, for example, employees dot exist. It's called contains key. Let's say, for example, 7788. You can say something like system.out.println. This is, and then I'll paste that. So it's going to be false because I don't have that employee, I suppose. So let's run that. So we can check if the employee exists. In this case, employee doesn't exist. You can give a different ID to check if the employee exists to true or not. You can also change the value of an existing employee by just putting it back. Okay, you don't have to really do anything. And as usual, you can also do a remove of an employee by supplying an ID, and that should be removed. Okay, that's basically a map, and you can change this to, say, for example, okay, so one problem here is, let's just use a print statement. So we're going to say here for employee EMP in employees, and we're going to say here that EMP is already an existing variable here, so that conflicts with the scope. So let's say, for example, EMPL I give. What's happening here? Oh, my mistake. Sorry. We are not using a list or set here. It's a map. So you can't iterate over like that. What you can do is you can get all the keys first and then print them. So this is what I'll do. I'll say here for, you can say integer key in employees.keyset. It's called keyset because it's a set of keys. Why set? Because it's a unique here, no duplicates. Now I can just type here s out system.out.println employees.get of key. So we want to pick up one key at a time, like 1122, and then we say, hey, give me that employee whose key is 1122. I don't have to use an if condition to check if it exists because we are retrieving it from that list itself. So that's going to be the list of that. This is how you will have to iterate. Okay, one way to iterate. I'll show you another way to iterate also. So first get the key and then get a corresponding value for the given key. So let's add one more. So iterate over the key set and then get one employee for the given key. Okay, that's one way of doing it. Let's use a dash dot repeat of 50. The other way to repeat is iterate over all the values in the map. And that is where you can say for employee EMP in employees dot values. Sorry, it's called employee dot values. So you employee dot values will give you all the values, and employee is already there, so I'll call it as EMPL. And then I'm going to print here S out EMPL. So I'm looping over all the employees and then printing that. That's directly okay. So this is the value. So you can see that there is a one set of keys over here. For example, you can see that this is basically keys, right? This is called key set, and this one is called values. So you have keys and values. What are we actually looping over this time? Here we say looping over the key set. I get one key at a time, like double one, double two. And then I'll say, hey, in the employees, give me the double one, double two. Whereas here, we are just saying that, hey, give me all the values. What are the values? The values are these. So these are the values that we have. And we get one employee at a time and printing it directly. So if I try to run this now, you should see a second output, which is a list of employees again. The third way of doing, okay, is iterate over a collection of what is called entry, collection of entry, which is nothing but key plus value. So you have one entry object that represents the key. So for example, this whole thing together, okay, is one entry here. This is called one entry. There's a key and there's a value. Similarly, if you take this, there is a key and a value. That's an entry object. So there is a class called entry inside the map or hash map for map interface along with the hash map. So that is what you can do. So you can say here for let's say entry in I note that I have not declared the variable yet. Employees dot entry set, and that actually returns a value which I haven't declared here. So it's basically not giving an error. Remove unused label. That's not a label there. It says insert semicolon. Basically, it's supposed to declare a variable here. The variable would be called as entry from map, and here the data type is going to be integer and employee. That is basically the data type. So instead of doing this map.entry, you can import it because it's a static member. You can import it anyway. So you can just say here entry from this map. Okay, it is directly typing map.entry. Alternately, you can also import it and use that. Now I have this one single entry in the entry set. So I'm printing the key and value I can access, but we can say here entry dot value, get value. So get value and get key is there. So you say get value. So if I try to run this, let's also copy this and paste and run this now. And you can see we are able to iterate over all the entries in that. I get a key as well as a value. So this is the key here. If you want, you can type here entry dot get key plus something like this plus this. So we get the entry as well as sorry, key and a value as well. So that's key and then there is a value. Let me know if you have any questions over here. How map can be iterated over? Map cannot be iterated directly. You have to iterate over the key set or the values or the key value combination, which is called entry. So take a minute, see if you have any questions, let me know. Okay, no questions? Cool. I hope I've covered all the aspects of collections framework, uh, all this. Hash table is legacy. It's similar to hash map. The difference is that the mutable functions basically or mutating functions are synchronized. We use them in case if the hash table or if the data structure, if the map is being shared by multiple threads and there is a threat of multiple threads trying to mutate the data at the same time. So we go with the hash table instead of hash map. So linked hash map, on the other hand, preserves the order in which is it entered. You also have one more I forgot to mention called a tree map. There is a sorted map as an interface. So there is a sorted map. Okay, that sorted map. This one in implements. Okay, so the sorted map here is is a subtype of map, and it provides some contracts which tree map, not the hash map. So tree map uses that. So tree map again sorts that based on the key. So I can create a key here. Sorry, I can say here tree map, and and these will be in alphabetical order of the keys when I access next time. So in the previously, you can see that they're all like in the random orders, but this time around, it's all going to be in alphabetical. Incidentally, okay, it's not sorry, it's not ascending order, but this is the last one. This is the first one, coincidentally. So let's give it a try. So first and last won't be changed. And you can see here that 1122, 2122, 2155, 6726, 677, 777, 678, and 22 and 7833, and then you have the 9822. So we got the ascending order by IDs. Okay, and that is tree map. If you think that the output or when you retrieve the data, you want them in ascending order of the keys, then you can use this one. Not needed though. Again, internal usages, binary search tree, which is a specific one called red black tree, self-balancing. Okay, what next? So let's go and have a look at something called streams, which was introduced in Java 1.8. And the first interface I want to look at is called consumer. Consumer, you can see that now they introduced all this actual package java.util.function in version 1.8 to provide the functional programming in Java. So if you look at the consumer, it is a functional interface. And mostly whatever that I'm going to look at is going to be functional interface. What does it do? It has a function called accept. If you forget the name of this, it doesn't return anything. It just takes one parameter. Basically, a consumer represents an operation that accepts a single input argument and returns no result. Unlike most other functional interfaces, consumer is expected to operate via side effects. So let's see what is the meaning of this. Let's go try something. Let's go type here consumer demo. So imagine I have a list. I am going to take this set demo where I have all these. I think I have one more comparator. Yeah, I think I'll take this one. We have a set of employees here. So this is the set. I'm going to take this as a list. You can use any of them. Any collection is okay. So in the main, I'm going to say here this, what is employees? It's going to be a list of employees. Let's create that. Employees equals to new array list, and this is supposed to be imported, and we got the employees. Now, let's say I want to consume one employee at a time. What do you mean by consume? I want to do something with one employee at a time. So this employees has a function called for each, like this. And note the argument here for each is a consumer. So I need to supply consumer object, and we know that it's an interface. We need to create a class, etc. So in other words, I'll have to type here new consumer of employee, and here is where I have the employee object received. Maybe I'll call it as EMP or just E. And here is where I can say S out E. So I'm printing this stuff. So basically what happens, the for each function gives me one employee at a time. Note that I'm not using a loop here. Am I? Loops are all keywords. For loop, while loop, do while loop, they're all keywords. And I'm not using any keyword here. It is a function in the employees, which is a list. A list is a collection. And if you look at the collection, collection from java.util, there is a function called for each. And this function comes from collection, isn't it? And since 1.8, what does it do? And you can see that it's not doing anything basically. It just is a dummy implementation, and it requires a not null. Basically, it's going to check that if there is any null, it's going to throw. But we are overriding this function, by the way, right now, right? And internally, it is nothing but a for loop. It is internally using a for loop, and it is calling the accept function. So in other words, the accept function that I have written, imagine this is called as action. Action.accept is called inside using a for loop behind the scene. But this being a functional interface, I can pretty much say that I don't need any of these things and put an arrow here like this, right? And I don't need this extra bracket. So now you see I have a simplified entry, and also I don't need this employee also. Everything is fine here now. If there is only one line that you have to do, you don't need that curly bracket also. So we can get rid of all these things and put it like this now. So we are saying, hey, for every employee, give me that employee, and I'm printing that over here. So if I try to run this now, it's supposed to print me all the employees one by one. So I can actually do anything I want with respect to this employee. And note that this is all basically what do you say, references. So instead of printing that over here, I can also say, let's do a statement chaining for every employee. For each employee that you give me, I want to set the e.set name to e.get name dot to uppercase. Let's just try converting that into an uppercase. And notice that the for each cannot be called twice. That is a problem. You cannot call it because for each doesn't return anything. Okay, it doesn't return anything. It's the void. So if at all you're using that, it should be the last one. So what I'll do is I'll split this into two. So I'm going to use here employees dot for each second time. So I have one for each that is setting the name of the employee, but will it mutate? That's the question. So this also I'm going to just type here E and save it. Okay, so let's try running this. And you can see that the names are all in capital letters. So the previous for each modified the actual content. So if you look at the for each function, that's what actually it said. For each, it says that performs given operation with some side effect we saw somewhere. Consumer, sorry. So I went to the consumer here. The consumer says that uh, there will be is expected to operate via side effects. There is a side effect. So when for each is called over here, the side effect is that the names got changed, and but it doesn't return anything. Okay. All right. So a couple of things that we can try now in the same style. For example, there is a function called stream. In collection, there is a function called stream. What actually it does stream is it's going to provide another object that has got more capabilities. So notice that here we have a function called for each, right? So we saw that the function called for each. Okay, it is there. I don't know where it was not seen. I think it is coming from the iterable, so it's not showing. Inherited members I have to enable. And then you can see there is a for each function over here. It's coming from iterable. But limited functions, mostly to do with how a collection can be created, how can we add an element, how can we remove, etc. But look at that, there is one function here called stream. So it returns an object of stream class. So let's go and see what is there in the stream. So if you look at the stream from java.util.stream, this provides many functions, many functions. Now the best part is most of these functions return a stream itself. Okay, it returns a stream. So usually if you have come across with something called as a builder pattern, even there also we'll have the similar one where it adds something, it builds something and then returns the same object, which I can again use it to build something else. Anyway, so don't confuse yourself, but look at this here. There are many functions. Some of the functions that I want to look at is called map. You can see that there is something called map. There's a function called filter. These are the two most commonly used functions, but then there are others also. Like for example, collect. We'll use a couple of these functions, okay? There is a distinct, there is a count, etc. Count returns a long, by the way. So you can simply say. So what you do is now you have a list, and then we can say, let me just use a print here, dot repeat of, say, for example, 80, just to print a line. Then what I want to do here is to, I want to get only the names. I want to print only the names of the employees in the, let's say I want to get a list which contains only the names of the employees. Okay. So I can say here employees dot stream. So we get the stream, and then you see you have access to all the stream functionalities. One of that happens to be map. What does a map do? Map takes an input, which is one employee object, and returns something else using that employee object. For example, I can say e dot get name. Now, the next one, if I type here dot, you can see if I type map, for example, what I get here is a string. You can see that it's going to get a string object. Okay, because now this is where the a list of or a stream of employees is converted into a stream of strings. See here, it is a stream of employee. Here it is converted into a stream of strings. So, for example, if I type here dot for each, give me one name, and then I can say print that name, system dot out dot println. What I'm getting here is just a name. It's a string. So we have converted a stream of employees into a stream of strings, whatever you want. Okay. So the job of the map is to transform one stream into another stream. Remember, so the number of inputs is like n, number of outputs is also n here. So if I try to run this one now, so you're going to see that you get only the names being printed here. Names being printed. Why? That's what is going on here, isn't it? If I didn't do that over here, if I comment this line right now, you can see what we are getting here is, even though I say name here, it is an employee object. This is printing an entire employee object. You can see that the last output will be a list of employee object now, right? So the moment you introduce a map, it is basically converting an employee into a name. Okay, name employee into a name. Now, this is something that is very useful. A lot of times we want to convert something into something else. Okay, very, very useful over here. So let's say, for example, I want to display only those employees who are earning more than 40 or more than, let's say, 50,000. People who are earning more than 40, let's say more than 40,000. Or, okay, let's do one thing. Let's change somebody to 5 here. And I think it's okay. Anybody who's earning more than 50,000, I want to reduce, but I want to display only the names of that. Of course, you can actually get an employee and then print employee.name here if you want. I want to reduce this also. That's why I want to show you this. Before using the map, I have a stream of employees. Now I want to filter all the employees. So I can use a dot filter and then say that filter takes an object of something called predicate. If you look at what is predicate, again, it is from java.util.function. Predicate is also a functional interface. If you supply an argument, it should return true or false. That's all. We get one argument. If you write a class that implements predicate, our test function, what are the function? Forget the name of the function, okay? We get one employee object, we need to return true or false in our case. So we get an employee object, we need to return true or false. If you simply say true here, that means irrespective of the employee, we're returning true here. That means what? All the employees will be listed. All the employee names will be coming, right? But if I say here false, for just for the sake of that, false, let's say false. Now you see none of the names will come because I'm filtering out all of them. So the condition that you return should be using the employee. So what I'll do here, I'll say e.getSalary is greater than or equals to 50,000. So now you see I have a condition. So the return value from this depends on what is the actual salary in the employee. That actually gives you a filtered result. That means out of 8 employees, I suppose, 9 employees. So I have 8 here. So no, I think here 1, 2, then 3. So 3 employees are matching this condition that I've given, matching the predicate I've given. So 3 employees. Now that means a stream of 8 employees is reduced to stream of 3 employees. And in that employees, 3 employees, we are converting each employee into an employee name. And then every time I get a name, I'm just trying to print it out. So you see that I should get only 3 employees over there. You can see Naveen, Neeraj, and Neeraj. Coincidentally, Neeraj and Neeraj. Let's change Neeraj to Neeraj Singh and Neeraj Kumar. Okay, so let's just change it so we'll know that we are getting all those employees who are earning more than 50,000, more than or equals to 50,000, right? So let me know, guys, if you have a question about this one. So a stream, because now the content is flowing. So while it is flowing one at a time, we are actually processing. So one element is given, we get the salary, check the salary. If that element is satisfying this predicate, then that is going to go here. We convert that employee into a name, and then we are printing it. And this is like it's going one by one, behind the scene. That's how it's going. It's not like we are doing everything here and then we are doing everything here. No, it's not like that. You take one employee, check if this employee is supposed to go through that filter. If the answer is yes, then filter that, then pass it here, then convert that, then print it. And that is going on in a contiguous fashion. It's not like, we process all of them together. Okay. All right. So what if I don't want to print it? Instead of printing, I want to get into a list here. So what I can do, I can use here, instead of for each, I can say dot collect, and I can say collectors dot to list. When I give like this now, the return value of this function collect changes to a list here. You can see here now, if I move the mouse, it should say, I can't, but let's say here, list equals to I give, and I haven't created the variable. If I create the variable here now, you can see it says list of string. How did it figure that it's a list of string? You see, the map converts an employee into a name. If I comment this line here now, just like this, okay, if I comment this line, this is giving an error because it's not a list of string anymore, but it's a list of employee, right? Because filter is giving a list of employees which are filtered, right? So the return type of this depends on what is happening here. So if I do a map, then it is a list of string. So similarly, it's a list of string right now. Let's say instead of to list, I'm going to call here to set, right? So I have a few options here. To set. If I do a to set here, you can see automatically it's a set of strings that I'm going to get. So if there are two Neeraj, only one Neeraj will go through that, right? So that's why we don't want to use the to set. We want to convert that into a to list. So if you look at that here, there is a dot to, there is to collection, to set, to list, most of them. And then to map also you have. You can convert that employee into an employee ID and a name, for example, if you want. I'll show you how you can do that. But right now, let's use the to list. And then we have a list here. And then we can actually say that the list consists of this. So maybe I can simply say S out list. So your original employees is intact. There is no change in that. We are actually trying to get that into a list of strings over here. Okay. So those are the 3 employees who are earning more than 50,000 rupees. Let me know if you have any questions over here. Okay. Now, sometimes, let's say, for example, in this case, imagine I haven't done this uppercase here. So imagine I haven't done this, okay? Let's comment these lines. I don't need them, okay? So right now, if I run this, I'm going to get the list of employees who are earning more than 50,000. So I got it. But let's say I want to convert that into a capital letter. So what do? Anywhere, either after you get the name or before you get the name. In this case, I better do it after get the name. I can say here dot map. Now I get one name here, and I want to return the name dot to uppercase, right? So simple case here, simple one. But this is too much to do here. What is happening here? I am getting an object and I'm returning using that object to call a function, and that object is nothing but a string. So I'm calling a string function. So this one can be simplified now. How to simplify this? So I'm going to copy this and comment this line and paste it back there. So I want you to know what's happening there. We know that there is a function called to uppercase in the string class. Whatever the parameter I'm receiving, I want string.to uppercase to be called on it. So I can simply say here, like this, string double colon to uppercase without calling that. Note that I'm not calling the function. I'm only giving here what is called as a method reference. I'm telling the map that, hey, use this function and call this function on the object that you are receiving. What is that I'm receiving here? I'm receiving a name. So on the name, to uppercase will be called. That's it. So if you run this now, you should see that the names will be in uppercase letter. Right? So it's in uppercase letter. So the same thing I can apply on any function for that matter. For example, let's say I copy this and paste over here. I don't need the variable though. because I'm not going to collect it. So I will remove this one to uppercase anyway we have seen. Let's say I want to print all of them. So again, we'll say for each, and then we say here, you give me one employee, I want to print that, right? I want to print that employee like this. So what we have to tell now to the for each function is that, hey, right now what for each is doing, for each is giving me one object. I take that object and then pass it to the system.out.println, isn't it? I'm not doing anything. I receive from for each, I'm passing it to this print function. Can I ask for each to do that by itself? Why I should do that? Why should I receive and pass it to someone? Why should I be the mediator? Instead, I can say that, hey, for each, why don't you call the println, which is there in system.out by yourself, and pass this employee as an argument to that. So to do that, we'll simply remove this, and then we give what is called as a method reference, like this, okay? And no need to call that. We are not calling, we are simply giving a reference of the method. Where is that method? The method is in this object, and call this particular function for every object you have. Don't give it to me. You call it that. So in this case, for each itself is actually doing the job. So I'm going to copy and paste that here and show you what does it stand for. Basically, it stands for give me one employee and print that employee, right? Print the employee. So instead of me doing that, me receiving it and passing it to someone, that's what I'm doing. I'm receiving it from the for each and I'm passing it to println. Instead, I'll ask the for each to call this function on for every employee. And the outcome remains the same thing. So you can see that there'll be a list of employees being printed now. List of names, basically, because I'm converting that employee into a name here, isn't it? So converting that into a name. If I don't want this, probably because we have already done that. So we should see a list of 3 employees along with their data. What is their salary and stuff like that. Okay. So this is called as a method reference, which is very useful. A lot of times we can use this. Okay. Do tell if you have any questions. Okay, since nobody is saying anything, I don't even know you guys are here. But I assume that you guys have no questions. That's what I'll assume. Okay. So streams are very, very powerful. Okay. So you can reduce lots of lines. Consider this is one single statement for the entire execution. So this is one single statement, not multiple statement, because it's one, there is a semicolon. There's only one semicolon, isn't it? Okay. So map, filter, collect. These are some of the important functions we have. I don't know if let's try something else here. Dot. Again, give me the topmost element like this. Reduce is another one. So skip sorted will sort basically. It's going to sort it. So for example, after, not before. I think I messed up. Let's undo that. Okay, so let's remove this. Come back here. So we have the employee, and we can simply say dot sorted. So remember, by default, it's going to take the help of the natural ordering. So all of them will be based on ID. Let's do one thing. Instead of this, let's give around 40,000. Okay, so we'll have more employees to check. So sorted, and you can see that we are getting in the ascending order of the ID, 1122, 6726. Then we have 6726, same ID twice. Huh? I didn't realize that. 6726, 6726. Let's make this as 28 and check. All right, so 6726 and 6728. So then you have the, this also 7822. I think I made it as a, all right, so 2 nodes. So the IDs are in incremental order. But once again, you can also supply a comparator to the sorted function where you can say that I want this to be sorted on salary in the descending order. What do? You sorted, and then pass here a parameter E1, E2. You need to supply that in brackets. if you have more than one parameter. Then what I'm going to do here, double dot compare here, and then say here E2 dot salary, that is get salary, and E1 dot get salary. So that actually takes care of sorting in reverse order of the salary. Isn't it so simple now? I mean, if you're not familiar, it might look complex, but once you understand the concept, you can see comparator I can apply wherever I want. So I can run this, displays the result in descending order of the salary. Let's hope 65,000, 65,000, 55, 600, 45, 600, and 45. So we get that in that fashion, right? So this is basically over here. Okay. What else I can do with this one? So many things. Uh, it's more like a select statement. Like you have in .NET you have a concept called what is that called? A link queue, LINQ, link queue. So link queue is similar to this one, okay, but except that we don't do the stream there, but we can do pretty much all these things over there also. But here it's much elegant now. There it is more like a select statement. It looks like a select statement of SQL. Okay. So that's about collection framework. I hope I've covered almost all the aspects of what is supposed to be covered in the collection. Let me just check quickly. Here, I don't have the syllabus here. So let's go to that. So I can add this into the code and then I can check right in VS Code here. So let's see. So we are in day 6, actually speaking. Let's open that once more. Day 6 is Java collections, generics, annotations also. Annotations, I think we will do it another day. There's nothing much that we can do with that. It's just that we use annotations. That's all. Okay. So, but generics and Java collections is fine. But I also want to do one more thing. So we want to combine the collections. Basically, this interfaces. Remember, we have done interfaces here. Okay. Where is that interfaces? OOP, basically. Yeah, here it is. So we have here interfaces we did in day 3, then we did exception handling, then we did the databases, then we did collections. I want to combine all of them and show you how you actually build applications in multi-tiered architectures. Okay. But for that, I want to take a break, maybe around 14 minutes, 15 minutes. I want to take a break. So we'll take a break now and come back by 3:10. Okay. And then I want to show you how typically multi-tiered architectures work and how do you handle exceptions? How do you use effectively these collections, interfaces? There is a pattern that we use, something called as a factory pattern or factory method pattern. Uh, all those things I want to show you with 1 hour of examples. Okay. So let's take a break and come back by say 3:10. So, okay, guys, I just created a new project called as mini project. Then I have started my Docker where I have the MySQL running. So I can use my workspace, the workbench, MySQL workbench to check out. Let's go here. All right, so I have the databases and all running. And I have one employees table here. So the amount of data we have, on the other day we were adding something. So we have some, 1,000 rows. Basically, I have lots of rows here. I don't need all of them. So, but we have this, right? So let's try creating an application that can give me data, you know, and process that in a multi-tiered architecture. So I want to give an idea of how these multi-tiered architectures work. Let's go to the image and make this page width. So in an application, usually there are four layers that you can think of. One happens to be the presentation tier. So this is the presentation tier. Takes care of, you can say, input/output from the user. Okay, input from the user, output to the user. Then you have another layer which is called a service layer. So the service tier, also known as a business layer. Okay, and that is because bulk of the business logic that is required for your application would be kept over here. For example, in a banking application, let's say registration of a customer, opening a new bank account, or transferring funds from one account to another account, applying for a loan, the customer applying the loan processing, for example, closure of a loan. So all those things are specific to the banking application. So those are the logics that are required. How do I transfer? How do I open a bank account? How do I apply for a loan? Or how can my loan be, let's say there is a calculation of an EMI to be done. So how that logic works. So all those things will go over here. There's one more that we will be having here, generally called as a DAO or a repository layer. So the proper name is repository tier, also called as DAO, data access objects. These are the three primary layers. And of course, you will also have your storage or persistence layer. So persistence layer or tier. Also known as EIS, Enterprise Information System in case of a Java EE applications. These are basically storage of data storage. And the typical ones are RDBMS, or let's call it as DBMS because I may have a NoSQL DB also. It could be an ERP like SAP. It could be a simple file like flat files, like CSV, JSON, XML, etc. So again, could be many others format. So this is how it is done. Okay. So whenever a client makes a request, the request from the client is going to request from the client will be, okay, that's not a good idea. So let's remove that. Let's say here, man. Okay, let's take this. So take man, woman, whatever you want. Okay. So when a client makes a request, the request goes to the presentation tier, and the presentation tier is supposed to collect the data from the user in case if user is giving some data, do some basic validation and stuff like that. If there is any problem, give the response back. But otherwise, forward that request or whatever the user's request to invoke a business logic function. The business logic function does some business operations. For example, like I said, transfer of funds may want to reduce balance in one account, increase balance in another account, calculate the commission amount, or some taxes or tax available, something like that. Okay, so all those things are going on here, but ultimately that has to either retrieve the data from the DB, what do you say? Um Retrieve the data or update the data, etc. So for which it's going to collect with the repository. Here we also write basically persistence mechanism, right? Mechanism. So basically how to store, retrieve data from the underlying storage media or persistence media. And that is what the question is going to be. And then this one is going to store, retrieve whatever from that. If you are retrieving, you're going to get some response. If you are actually storing, you will get some kind of acknowledgement. Then this is going to, let's say, for example, you access the data. Let's say the client is trying to log in. So basics, if sometimes if there is no logic over here, you simply delegate it to the repository. Let's say you're trying to get the list of all the users by that username, and it should be 0 or 1. And we supply the email to the database, and the database comes back with the image in one record, and that record is checked. We convert that record into some employee object or user object, gives it to this logic, and this probably might want to store it somewhere, and or maybe record the information, and then eventually it says, okay, presentation says, hey, welcome, Vinod, you are successfully logged in, so welcome back, something like that, right? So that is what basically this whole multi-tiered architecture. In case of an error, for example, imagine you tried to look for an employee, and incidentally at that very moment the DB was down, and this is trying to retrieve the data from the DB, but the DB is down, so you get an error. So there is an error created. The error object is nothing but an exception object that is thrown to the service layer. Now the service layer is not supposed to catch that and just print something like ex.print structure. That's the worst thing that you can do, because then you're telling the client or the presentation tier that there is nothing wrong. I had an exception, but I've already handled it. And because there was no problem received by presentation tier will simply say, hey, everything was okay. Imagine it was in the case of a fund transfer, and the fund actually was not transferred, but here it will say fund is successfully transferred. That is wrong, isn't it? So whenever there is an exception thrown, the only thing that this has to do is to propagate that exception back to the service tier. Service tier should propagate it back to the presentation tier. The presentation tier should catch that exception and then print an error message properly to the end user. So this is what actually we need to do in typical applications, okay? And this kind of exception propagation is called exception funneling. So you don't process that unless you are a presentation tier. So until then, you just transform that and send it across. So to demonstrate this, I want to build an application that makes use of this employee table, where I have this employee number, first name, last name, email, phone number, salary. These are the fields that I have, and I want to retrieve this from the DB and then provide few operations. Now we already have. If you look at this, we already have this layer. So I'm going to put that in green. We have the employee table, MySQL. Now, this repository tier is where we want to focus on. And we always follow an approach of loose coupling. So what is loose coupling? You write an interface. So your application here, the service tier, uses or makes use of the interface variable here. But at the runtime, we get an object of some class. Right now, we are going to create a class that implements the interface using JDBC. But it could be tomorrow something else like JPA. I think in the next session, we will look into something called JPA, because I think we will look into these annotations also, because there's some annotations that we wanted to cover, right? So we want to cover something. Before actually going into this Spring, we want to introduce JPA, Java Persistence API. So that's like a kind of an advanced, or you can say enhancement to JDBC or wrapper to JDBC. So that I want to cover. At that time, we can also re-implement our DAO. Instead of using a JDBC, we can use JPA. It becomes very, very simple. All right. So right now, I want to introduce that with the help of a simple JDBC code. So let's go here. First, let's define the entity class. What is entity class? The entity class is something that is connected to the DB. So you have here the employee record. One record, if you take, I want an object that represents this, which means I need to have a class called employee with a member variable called maybe ID, first name, last name, email, etc. I can even call it as emp number, but I think it's called ID is emp number is, I don't know, not really a good name in the Java. So let's create a new package first. Couple of packages. Com.target India is the first one, and inside that I want to create a new package called let's say entity, and then one more package I want to create called let's say repository, and let's create another one called service, and another one called probably UI for user interface, and anything else like utils. So I'm going to create a couple of utils here, like keyboard util, DB util, etc. Right? And anything else I missed, I will give that later. Okay. I also want to create a resource file here, which is called jdbc info.properties. And if you remember, we did this in the previous JDBC demo class. I think I remember doing that. So let's go to day5 workspace, SRC main resources. I have this JDBC info properties. I'm going to create that. So paste over here. Exactly same thing. There's no change over here. And I also had previously some DB util over there, both keyboard and DB util. So I'm going to copy this DB util from here. Create a new class called dbutil, paste it, keyboard util, which allows me to accept few type of values, copy. This is called keyboard util, and so we have a couple of copy paste things. That's fine. We also want some dependencies. What are the dependencies I want? I can get from the pom.xml of the previous one. What is that? We want MySQL. H2 is not required. I just need MySQL from here. I also use Lombok. I want to use Lombok. I can get that from here only. Dependency group ID. Okay, dependency artifact ID project Lombok. Project Lombok. Oh, okay, I don't think so. It is available. Let's do one thing. Let's get it from the net. So we go to the browser, mvnrepository.com. Look for Lombok. Get the latest version. Okay, artifact ID was Lombok. That's why I didn't get that. Copy and go back over here. Paste in this section. I don't need that scope over there. So I can also use logging. You remember the logging we have done earlier somewhere. So let's go to slf4j. Okay, so I have this pom.xml here. We have the API log4j. So we're going to copy these two, add that as the dependency. SLF4j also expects one file here called log4j properties. So let's add that file, log4j.properties. And a default logging that I want to use would be from here, src main resources, log4j properties. I want to copy this and paste just like that. Let's get rid of file appender. We can keep that in the file appenders instead of just the console. In fact, what we'll do is we'll use the file appender instead of the console appender. So I'm going to remove this, and I don't want the console appender at all. I don't want this. I'm going to uncomment this. And now anything that I have, any activities will be logged in app.log or any other file name, app log underscore txt if you want, something like that you can keep. So the file name itself is something that you want to customize that, right? So I believe this is fine. I'm just going to do a Maven reload to get all the dependencies here, external libraries. I should see that now. Okay, so let's go click on this external libraries. You can see I've got all of the libraries ready. Okay, so let's move on now. So first thing I want to do is to create a interface, entity class called employee. So I'm going to create a class called employee, and under entity, and I'm going to go give here some variables. Let's say private int ID, private string first name, last name, and private string. No, I think not string. Yeah, email, string email, private string phone, private string salary. Oh, that's double. So it's always a good idea to use D capital, so you can also represent null values, but my coding becomes a little complex, so I'm just going to leave that as it is, okay? And because we are using Lombok, we can simply say at the rate data, and the data introduces even the hash code and equals also. That's why I didn't use it earlier. You can see that there is a hash code here, and there is an equals function somewhere here, right? And this is the reason why I didn't use that. I wanted to show you without the hash code equals what happens, and then I had to manually generate that. But now it is okay. So we have got a very simple mechanism. So let's leave this. Now I'm going to create a repository, which is an interface. So I'm going to create something called employee repository or employee DO. Name is okay. You can give any name you want. It's an interface. And here, typically you have CRUD operations and queries. So these are something that you might provide in a repository interface, okay, or a DAO interface. So the way you do is you write a function public. The return you provide one function for create, read, update, delete each, and then provide some queries. And the CRUD operations work on an object. For example, the create function should take one object and store in the DB. That's all its job. Retrieve function should retrieve the data based on an ID. Update should update the data in the database. Delete should delete the data in the database. That's all. But these are interfaces, please remember. When you created, I don't remember, I think it was an auto increment, if I can recollect correctly. It was an auto increment. Let's close all this and minimize. Day 5 workspace. Okay, where's my SQL command? Don't remember. Okay, programs, insert employee record. Okay, null. That means it is auto incremented. I think in the create table, there no create table. Create table was created in the, I don't know how I created this, I forgot. So, but anyway, it's auto increment, right? Maybe you want to return the ID generated or return the employee with the ID generated, if it is generated at all. So either way, it is your choice. Okay, you can make it as a public integer, create or add or save, something like that. Insert one or something like that. So it's your choice what you want to insert. So the return value, let's say, for example, I want to keep that as an employee. So I want to supply an employee object. Let's call it as insert. And I will supply an employee object, employee. Maybe I can call it as employee. And any exception that is received by this function internally, it should wrap that in something called a repository exception or DAO exception. But I don't have such a class. It's giving an error. What do? You go here, press Control-1, create a class called repository exception. And notice it's going to be created in that package, com target India repository. I say, okay, fine. Automatically, it came as this. Now, if you don't want this to be a checked exception, just change this to a runtime exception. Then it becomes automatically an unchecked exception. So choice is yours, but let's keep it as, let's keep it as runtime exception. Okay, runtime exception. Okay, and this is just to have some constructors, nothing else. And generally, the constructors that I'll take is this, and then this one. So 3 constructors I'll add. The most important one in this scenario is this one. Whenever you receive an exception, you construct a repository exception and throw it. That's what you can do. So that's very simple. Let's keep it like this. And now this function is ready. Note that here the argument, you will not have an employee ID. The return value will have an employee ID. The rest of the details will be same. So, but there's an interface. Anyway, the second function is going to be public employee. Let's call it as get. You can say find by ID if you want, because in JPA a very similar function is there. Let's keep it like that. Int ID or integer ID throws a repository exception. In case of a problem, it's supposed to throw that. That means whoever is calling this function, they should be ready to catch this exception. Okay. Then we'll say here public employee. I don't think so. The return value should be there, but let's call it as update. And we supply employee object and throws repository exception in case of a problem. So let's say that's throws. One last is public employee. This is to delete, so I don't need to return an employee. Let's say we say this public void delete. And maybe if you say, give me the deleted employee after that, so probably you can return that employee also. Again, you can change this later if you feel like. It takes an int ID or integer ID and throws the repository exception in case of a problem. Okay. So those are the 4 CRUD operations. Majority of the occasion, we won't have this because this is going to permanently delete the record. But instead, you may have to do something called soft deletion. So soft deletion is where the employee record exists, but whenever you try to retrieve, it won't come because you will have one flag variable like, he is active or something like that, where you will have, for most of them, you'll have true. But for the employees which are deleted, you will say is active is false. So whenever you're trying to display the data in the dashboard, you may say select star from employees where is active is true, something like that, right? So that's basically the the CRUD operations. Now I have queries. Let's say, for example, I want the list of all the employees. So public list of employee. See, I'm not going to say array list here because that becomes tight coupling. So the implementer of the implementation of employee repository interface then will have to return an array list all the time. But what if when I'm implementing, I figure out that, okay, getting a list of employees is better if I'm using a linked list. And if that is the case, then you will not be able to do. So that is the reason why we want to do in the we want to do in this format. So let's say here it's a public list of employee. We'll say here find all throws repository exception. Similarly, let's say I want to search employees who are I don't know, maybe with the last name. That doesn't make much sense. Let's say an employee, I want to find an employee by email for some reason. So this would be one employee, public employee, because at the max for a given employee, email ID will have only one employee. So I'll say here find by email, and let's give here string email, throws an exception, and then we'll say public employee, right? Find by phone, we pass a phone and throws exception, right? Oh, that's supposed to be a repository exception everywhere, not just exception. And maybe I also want all the employees, list of employee by last name. Let's say, for example, find by last name, right? And string last name is what I'm going to supply. Throws and repository exception. One last I want to give is public list of employee, find between, I don't know, between salary of, let's say, double min and double max, throws and repository exception. Find between salary. That means I'm trying to find the employees who earn the salary between this and that, right? Or find by salary and give a minimum value, something like that you can do. Find by salary. Usually when you say by salary, we are expecting an exact match. But here I'm saying, we can say find. Let's keep it like this, simple. So you can add as much as queries you want. Now, if you look at this interface, we have never mentioned that this should get the data from the DB, isn't it? We never said that it should get from MySQL or MongoDB or from a CSV file. And that is what is actually loose coupling means. Here, this guy, this concepts, if I go, you look at this, the service layer is the one that will be making use of repository, and service layer is totally unaware as how actually the data is being retrieved or stored. It is not the primary concern. That is what is abstraction, isn't it? So this basically gives you a complete abstraction. We are hiding the implementation details. Now, this could be implemented using a CSV, or could be implemented using a MongoDB, could be implemented using MySQL, or any other mechanisms, right? We are not interested in knowing that. So the service layer will simply say, give me an object of employee repository. I want to insert a record. I want to find the record by this ID. Now, where are you going to get it from? None of my headache. So it's yours. You do whatever you want. So that's where the loose coupling, that means service tier loosely coupled with the repository tier or the DAO layer, right? So let's try to implement this class, that interface, by going to a new Java class. And I can implement that using CSV also, or an Arraylist or something. But right now I want to implement using a JDBC. So what I'll do is I'll simply say JDBC employee repository. Now notice the name here. This is the interface that this implements, and this is a mechanism through which it is implementing, or what does it implement, how does it implement. Now remember the array list, the name array list, right? What is the meaning of array list there? It is an implementation of a list interface, but using an array. So it's like this array, and this is like the list part, right? So it's an interface being implemented and the method. And it's a class that I want to use. And here I'll say implements, and then I have to provide that employee repository. And as soon as I do that, it gives me an error. And quick fix will allow me to add all the unimplemented methods, all of them. So I have all these functions now, right? None of them are working right now. So ideally, I should throw a repository exception saying that not implemented yet. That's the starting point. You should implement by default all the functions as that they are not implemented yet. But let's say we want to now try inserting the records and stuff like that. Okay. How do I do that? So this is where I want to write a query. In this case, it's an insert statement. I can have here a static final string called insert command, or insert SQL, equals to insert into employees. Note that the first, you can say here values, question mark, first one is the null employee number, I don't want. Then I have how many columns? I have here employee number is going to be auto-generated. So 1, 2, 3, 4, 5. So I need 5 question marks with commas in between. Okay, so that's basically the insert command that I have. Similarly, I can have here static final string update SQL equals to update employees, set first name equals to question mark, last name equals to question mark, email equals to question mark, salary equals to question mark. What did I miss? Email? No, phone. I'm sorry, I don't know what happened. So I need to say here phone equals to question mark, and salary equals to question mark, where emp number equals to question mark. So that's the last one that we have. Either you can do like this, or you can actually declare it inside that itself. Let me just use the insert command first, and then I will do find by ID, and then I want to do find all. So I can give a demonstration of that, and the rest of them, you can try to implement that, okay? So let's get it off. Let it be there anyway. So now here is where I want to use a try with resources block, and any exception that I get, okay? Any exception, doesn't matter what it is. I simply say here, throw new a repository exception of EX. Notice, this is the reason I told you that it's important. This is the most important one, because whatever the exception I receive, I'm simply forwarding. But it's also a good idea to log all these things. So I can type here log.warn and then say that got an exception you actually can just type here EX like this. You don't need to do anything. You can simply supply that also. EX is the exception. So I think warn doesn't just take the throwable, it has to have some message, unfortunately. So let's take that message, message saying that got an exception. You can also say while trying to add, trying to insert employee record, and the EX is the throwable that we got, and that's just a log. So this becomes common code for all my functionalities, okay? What am I doing here? I want to get a connection. So I'll say connection con equals to dbutil dot create connection. I'm going to use a prepared statement because it has got question marks, parameters. So I'll say prepared statement stmt equals to con dot prepare statement of insert SQL. And that's the 2 lines. Now I need to insert pass all the values to the question mark. Note that the first question mark expects first name. So I'll say here stmt dot set string. The first question mark is nothing but employee dot get first name. Like this, now I have to set for all of them. Get last name, get email, get phone, and the last one would be a get double, set double here, and that would be employee dot get salary. I have also to say here this is 2, 3, 4, 5 question marks. This is going to be last name, email, and phone number, right? And now I'm ready to execute. I say stmt.execute update. It's done. However, if you remember, we also want to send back the employee with the employee ID. How do I do that? So that is where you may have to specify here, apart from the insert SQL, you also have to specify something called statement dot return generated keys. I hope you remember this. Last time we did this. Now we are able to get the generated keys. If there is any exception, it would have gone away already from here. But if I'm in line number 32, that means there is no exception. I'll now say stmt dot generated keys, right? So that get generated keys, let's call it as keys equals to, and then create that local variable, which is the result set. And now I say here keys dot next. So I want to move it further. Now I'm in the actual first record where there is one single column which contains the ID generated. So I can simply say here return, no, not return, sorry. The employee that we have got called set ID. And here I'll say keys dot next get int of 1. And that's it. Now we can say return employee if there is a problem. If there is no problem. If there is a problem, we are throwing that exception. So this return path is not required. So this is how we have retrieved the we have retrieved the generated primary key value. We made that as the employee's ID. Remember, the user, when he gives, user is not entering the ID. User will simply pass this rest of the details. We generate the ID from the backend, we set it to this employee, and then we are returning. So whoever is calling this will now get the employee with the auto-generated ID. I'll show you that with the example here, okay? So I think I've followed all the best practices possible because I used a try with resources here. So obviously both connection and statement get closed over here in case of an exception or no exception. I've also logged the errors. In case of, let's say, for example, we are trying to insert the data, right? So we can type here log dot, maybe you can say trace, because these are some trace information, or maybe you can say debug information. Then you can say here the message is trying to insert, and then I'll just supply here employee dot toString, of course, but not required. That is automatically called. So the employee information will be printed in the log, trying to insert this employee. I think I've taken care of all the possible errors and stuff. We can now test this one by writing the service tier. So imagine in the service tier, we are supposed to get the object of this employee, what are the employee repository, and call that from, the user would have entered all the details, and we would have collected all the details and passing it over here as an employee object. And we want to ensure that the employee object contains all the values, like for example, salary is not wrong, email is supposed to be mandatory, like those kind of stuff, right? Email is mandatory, phone number is mandatory. If it is not there, I want to throw an error, etc. So this is where we want to write this layer. One example I'll do, and I think then we will be running out of time. We'll continue this with a next session. So I'm going to go to the service tier now. I'm going to create a class called employee manager. Now, sometimes people might also create an interface for employee manager, making it as loosely coupled. Now, whether it is required or not is something that you may want to do, because most of the time, this layer is very volatile. You may change this based on different implementations. Pretty much the business logic may not change, but if you have something like, for example, version to version, you may want to improvise, keeping the old version also, then you might want to have an interface and then an implementation. Me in this example, I'm going to keep this as a tightly coupled one. That means presentation layer tightly coupled with service tier, and service tier is loosely coupled with this. And this is also loosely coupled with this, because notice the coupling between this and this is that JDBC info properties, isn't it? Tomorrow, if I want some other database, I just have to go here and then change these values. That's all. I don't have to do any other change, right? In my JDBC, I'm just using that, using a connection. I'm never mentioned here anything about MySQL. It is about JDBC. That means there is some RDBMS, but I never said anything about MySQL or anything, isn't it? So tomorrow, if you want to check, that means the connection or the relationship between repository tier and the persistence layer is loosely coupled. And the link here is in the JDBC info properties. Now, in order to bring the same loose coupling over here, I can also have the same thing. Now, look at this DB util that I've written. We are using here driver manager.get connection. So I mentioned somewhere, I think, I don't remember. This is the reason why it is loosely coupled, because here we simply supply this URL and the get connection will make use of an appropriate driver object and then gives you all the connection statement, whatever you require, right? So this is called as a factory class, and we can create our own factory class also. Today I will not be showing because it will take more time. So maybe in the next session we will do that. So because it's important to understand the factory also. Today I will a bit of tight coupling will be there, but tomorrow I think the next session I'm going to show you how you can make this as a loosely coupled one using factory. So I'm going to create another one here called maybe repository factory or DAO factory, something like that. Anyway, here I have a function called, let's say, add employee. So let's assume that here it is called public employee. It's called add employee. And here we will say, we receive an employee object, and we need to add this to the database. To make use of the database, I'm going to use an employee repository. So let's call it as repo and equals to new employee repository. Oops, new, what is that called? JDBC employee repository, and that's actually called, this is called tight coupling. Need to get this object using factory. So we'll do that in the next session, okay? So we don't want to say new JDBC. We want to, just like how in the DB util, for example, although we are getting the data from MySQL, is there any mentioning of MySQL here? Absolutely not, isn't it? So your code is independent of MySQL. So likewise, your code should be independent of this specific implementation. It should be totally dependent only on this one. And to do that, we have to use something called factory. We'll do that next class, okay? The add employee ideally is supposed to say return repo dot insert and employee. That's it. However, because it's supposed to do some business logic, how about checking whether this employee contains valid values or not? Now, you may say, why don't we do that in the UI? We can do that kind of validation even here also, isn't it? But if that is something to do with the business logic, that means it's something to do with the domain specific, like in a banking application. So it is something to do with the banking application, it has to be there here. This is just a collector and presenter, nothing else, input output. So what we do is we check here whether employee first name is mandatory, salary is mandatory, email and phone number are mandatory, and stuff like that. And if email is supposed to have that, the regular expression, you can even try that also. Okay. But right now we will only check for mandatory stuff. So I'll say here, if employee.get first name, let's assign this to a variable. So string first name equals to this. If first name after trimming, if its length is 0, that means you haven't entered anything. You also have to check if first name is null. First name equals to null, or if it is equals to null, or if its length is 0, then you need to report this as an error. How do I do that? I'll say throw new service exception. Note that service exception, if you look at, it is there from Google. I don't want this Google. I want to create a new one. And I also want a message here saying that first name is required, but missing. Okay, some kind of a message. And it's a service exception. I want to create a new class. I don't want to really use the built-in one. And I'll say inside the service, I'll say, okay, this is fine. I'll create a new, basically generate constructor. Once again, these three are something that I would be using. So constructors, let's save it. Oh, why is that an error? It is checked exception. So obviously we have to throw here like this, throws service exception. So now I have no problem. So whenever there is a name is blank or null, so I'm throwing an error. Similarly, I'm going to say here string last, let's say salary, and salary must be not string, double salary equals to employee.get salary. Imagine the salary should be more than 15,000. That's the minimum salary we have, and it should be there. And if it is not there, of course, it's going to be an error. If it's anyway, it should be more than 15,000. So I'll say here if salary, because it is a D small, it cannot be null. So I don't have to check for null. But if salary is less than 15,000, it should be minimum 15,000. Then I'll say here throw new service exception of, okay, salary must be greater than or equals to 15,000. Some message that is suitable. But if it is not, I'm going to add that. I'm passing it on to the next layer. The next layer may do something, do properly, may come across with some error. If there is an error, that will come here. But remember, the insert throws what kind of exception? I think I made one small, not a mistake, but you can see here, I made this as a runtime exception purposely. Let's remove that. And now you see you get one error. Okay. The insert throws an exception which is supposed to be caught. So what do? You right click, I don't know, we have a surround. You have to go to this code, surround with try catch. And in the catch block, what you do is throw a new service exception. So you say here, throw new service exception of E. So we receive this repository exception, we convert that into a service exception. That means this layer will always get only service exception. So I can say here, expects only repository exception, right? Whereas this layer expects only service exception. I hope this is clear. So no matter what, because this is not aware of the repository layer, and this is not aware of your persistence layer, because here you may be using files. In that case, you'll get IO exceptions. If you're using MongoDB, you'll get a MongoDB exceptions, right? If you're using JPA, you're going to get some JPA exception, okay? So this should be transparent to that. So this should not be knowing different kinds of other exceptions. So the responsibility of this is to convert any kind of exception into a repository exception. That is what this is supposed to expect. And this will convert all kinds of exception. And if at all there is any exception thrown here, it is always going to be a service exception. And that's what we are doing. Here we are manually throwing. Here we received an exception. We are converting into a service exception. What's called as an exception funneling. Okay, exception funneling over here. So we have done the add employee now, and it's time for us to write a UI where I want to display. I want to accept the data from the user and then pass it on to this layer. So let's do that. We have only 4 minutes, but I think we can extend this by some 10 minutes. So we go create a new Java class. Let's call this as employee UI. We're just like employee service. We're going to create a employee user interface, which will have functions to let's say accept and add employee, right? So let's write here a function public void accept and add employee data, employee details. No arguments required here. And this is where I might want to tell the user that, hey, enter ID, not ID. So for example, I can say string first name equals to keyboard util dot get string, enter first name, and copy paste this a few times. This is going to be last name here. Two of these are going to be last name. This is email. We have here phone, enter phone. And one is double salary equals to keyboard util dot get double of enter salary. Now the user might make some mistake and enter a non-numerical value for salary, in which case it should display the error right there itself, isn't it? So let's try doing something similar. I'm just trying to format all this, so make it same line. What do you do in such case? You might want to tell the user that, hey, there was only one. I think this is the only one that might cause the problem. There is no other problem. But let's assume that it's not going to be. But if you want to make it foolproof, so you'll have to say here, surround with try catch. And what do? You say here that sysout, this time not log. You have to do enable logging, but lack of time, I'll not do logging. But I've shown you how to do that. Here you can say salary was expected to be a number. Expected to be a number. Okay, or you can say please enter number. Please input a number only. Now here is one problem that what if the user entered a string, right? This will skip and it'll come without the salary. So I'll have to assume that the salary would be 15,000. Or you can say invalid salary was given, and we can say invalid salary entered, assuming the default of 15,000. Okay, so which means you'll have to say here, let's declare double salary here, and salary you assign, and here you can say 15,000. So one of those two are taken. Now I create an employee object, employee emp equals to new employee, emp dot set first name of first name, like this. Now you have to do all of them. Set last name of last name, emp dot set salary to salary, emp dot set email to email. One last is phone to phone number. Now I have this. What do I need now? I need the employee manager. I can create the employee manager right here. Employee manager em or manager equals to new employee manager. And now I can use that manager dot add employee of emp, right? If this throws, because remember it throws an exception, I don't know what exception happened. For example, you did not enter the name, or you didn't enter the email, or whatever, the salary was less. Okay, if that is the case, this would throw an exception. So what do? You go here, surround this with a try catch, and in the catch block, just tell what happened. So that's e.get message. It's also a good idea to log this. I'm not really writing the logging, lack of time, but later you do that, okay? So now if there is any problem, it will print this. If there is no problem, now I can, remember I supplied an employee without the ID here, but by the time I come back here, employee will have the ID. Or you can probably say emp equals to that. And because here you can see that we are returning whatever the inserted employee with the ID, right? That employee comes over here. And now I can type the message saying, oops, not split, s out. we can say new employee or employee details added with ID of whatever the ID that I got. So that is your emp.get employee ID, right? So that is how you create this function for a UI. Now let's say we want to call this function now. This is the last part where I have to call this function to check this, isn't it? So what I'll do, I'll just write a program or an app. And directly I'll create a class under this called app. For the time being, I'm just going to go and call that function of this employee user interface. Employee user interface, let's call it this UI equals to new employee user interface, UI dot accept and do this. Now I'm going to extend this application in the next session where I want to display some menu to the user and then all the stuff, but hold on for that. But right now I'm just accepting this one. So it's going to accept one time and then quit that application. Hopefully everything is okay. So this is the user interface, and that is going to talk to the manager. The manager is going to talk to the repository. Repository stores the data in the DB. So let's run this. Hopefully everything is okay. Compilation wise, there's nothing wrong. Let's check it out. Enter first name. Let's see whose data is there. So okay, there are a lot of data. So with the last one, let's do one thing. I think all of them are there. I can even truncate and try that, right? So that's easy. Okay, 1002 is the last one. Let's try doing, say, for example, Kishore Kumar. Email is Kishore Kumar at example.com. Salary, phone number, let's say 9878965 234. And salary, let's say, for example, 75,000. Press enter, and employee details added with ID 1012. In between, there might have been failures, and that's why we get this 1012. Now, if I try to run this, I'll have to go down again to check all the values. I think I can scroll here. Yep, you can see. Oh, I don't see that. Why? Let's try here. I think it's showing only the first 1,000. You can say where emp number equals to or emp number greater than 1,000, and there are only a few of them. Let's try to run this, and the last one you can see 1012 Kishore Kumar, etc. Now suppose I want, and the application finished, okay, it is exited because I didn't use any menus and stuff. When I run this one this time, I want to enter blank name. I don't want to give the first name, but last name I'll type Kumar. Email is say Kumar at example.com. Phone number, doesn't matter what it is. Salary, what doesn't matter what it is. I press enter, comes back, first name is required but missing. That is the exception that I threw from my manager, if you remember, right? And let me run the same thing again, and I'll type here, say John Keller, and email, doesn't matter what it is. Phone number, doesn't matter what it is. And I will give a salary of 1,000. This should now throw an exception saying salary must be greater than or equals to 15,000. Let me add again another one. Let's say, for example, John again, Keller, and I'll type email is John Keller at example.com. Let's say some number, okay, and salary, I'll give it as, let's say, for example, now if I give less than 15,000, it's going to give an error. But if I type here, simply press enter, you can see that it says that, okay, it did not continue. I have to type something and press enter. Maybe I can give some space and enter. No, I think I have to type something and press enter. It says invalid salary entered, assuming the default of 15,000. New employee added with ID 1013. So if I try to run this, I should see that there is 1013 John Keller with 15,000 as the salary. So we have taken care of all our scenarios, all the scenarios that in this case, right? So this is exactly how you create applications, and it becomes now very easy to manage, because tomorrow if I have to, let's say I want to add a new employee, very simple, I want to retrieve the employee details. I go to the interface here. There is a function called find by ID, but in my JDBC, I haven't implemented that yet. So if I implement that right here, and then I will go to the manager. I will write another function to make use of that, and then in the employee interface, I will try to accept the ID from the user and then print the details. So that is what we will do probably on next week, along with doing something in JPA. We'll replace this with JPA. We'll also use something called factory, okay, to do all these things. So I hope this was informative, and I hope you understood certain things. If you have questions, you should have asked. Nobody asked questions. I have only 12, 11 people now. Let's do one thing. Let's stop here. I will push the code to GitHub. You have the GitHub link anyway. Okay, so I pushed the code to the GitHub. It is ready now there. Yeah, this is the one. I'll share the link in case if you have lost it. See if you guys can implement the code in the interface, the JDBC employee repository. And I will show you how you can do that, and then you can compare yours and mine. Okay. So all those things are there over here, whatever that I explained in the GitHub repository and the workspace with all the code. That's the mini project that I was talking about. Check that out. Okay. So that's it, guys, from my side. If there is any question, I'll be here for a couple of minutes. Otherwise, you all can leave the meeting. And if you don't ask questions, then I will end the meeting for everybody.